I'll probably do that, and then, okay, let's do that. All right, everybody, we're going to get started. We appreciate those that have come today and those that are standing and coming into the show. My name is Mark Marderziski. I work with Diamondback Nozzles, and we've got the Diamondback Nozzles crew here and the E3D crew. We've been working together for the last little while and just want to kind of walk you through our journey together. We're excited to announce a new product, Revo Diamondback. And so I'm gonna turn some time over to Claire from E3D. She and her team have made a great video. Oh, we've already got one that's been purchased, so gotta love that. But let me pass the mic to her for a second, and then she'll pass it back to me. And you're going to get a little bit of mics on the stage here. To be honest, this feels like we're riding on a ride at an amusement park. So I don't know what it looks like, but that's what it feels like up here. So enjoy the ride with us. We're excited to have you here.
Hi, I'm Claire DeFazio. I'm head of product strategy and marketing at E3D. I'm also the UK and Ireland manager for women in 3D printing. As Mark said, we've been working together for, I think we started talking, well, we'll go more into it later, but we've been talking for quite a while now and dabbling with various development projects. And this is the first one that we're really delighted to be able to show you. So I guess without further ado, let's watch the launch video, and then we can go into a little bit more detail.
Awesome. So we are so excited with E3D and their team. They put this video together, helped us put it together, and we wanted to just kind of walk you through the journey of how we've done this project together. If I can get this correctly done. I apologize to those of you that are sitting on this side of the presentation. You're going to feel like you're sitting on the sun with our white slides, so we apologize for that. But we wanted to give you a taste of how we have been working together. Our collaboration started a while ago, and we wanted to thank some friends. In this community, it's amazing. It's all about friends introducing friends. We're new to this industry. We're new to 3D printing. We've only been selling products here for about 2 years. And I have to tell you, I've been in business for 30, 40, our company's been in business for 30, 40 years. And this community is so welcoming. It's amazing. We really have enjoyed it. And one of the ways that we really enjoyed it was coming to Rapid for the first time was the first time we met E3D. We actually went over to their booth. We thought it was really cool. Saw some of their technology and just started talking with them. And it felt like family in a lot of ways. I have to just say that. It felt like family. They were very open. And so pretty soon they were over at our booth, and we just wanted to thank a few people. I have to actually thank Grant and Amber from 3D Musketeers. Those of you who know them, they're here in the audience with us. Grant was the first one to tell us, hey, you guys, you need to start working with the guys from E3D. Good people, good technology, and he really was encouraging to help us do that. Our Kickstarter campaign, the folks on Kickstarter, we're a bigger company. We didn't need the money on Kickstarter, but we loved the conversation that Kickstarter gave us because we wanted to hear from the community, and that's really what we heard. So that gives you a little bit of an idea. We just wanted to walk you through how we started working together. I don't know what E3D's perspective was, but that was ours when we started working together.
I think it's worth telling the story of Mike actually being one of your OG backers from Kickstarter.
Yep. That is the story. No, so at E3D we're always keeping an eye on everything new that's coming out in the market, and when the Diamondback nozzles came out on Kickstarter, we were straight away like, we got to get one of these. We got to see what's going on there. So yeah, I actually backed the Kickstarter in secret as a stealth, no E3D reference. Like, we'll just ship it to my house, and then we'll take a look at it and see what it is. So yeah, we've had one since the very beginning.
And yeah, in the meantime, luckily we started chatting, I think, even before you delivered the Kickstarter. So it's been a good journey. We've enjoyed it.
That's awesome. You want to add anything, Harris? Okay, we're going to keep going through. We want to walk you through three things. We want to walk you through how diamond is made, or how we make them. We'll walk you through that process. What are the benefits of diamond, and why did we put it on a nozzle? So here's the first part of how diamond is made. We're going to walk you through. I'm going to speak over this video as it goes. What we have a facility based in Utah, and you take diamond powder. This is synthetic diamond powder. It's the consistency of flour. You put the diamond powder in a canister. Then that canister has all kinds of technology included in the canister, but it's basically put in a cube assembly, and there's a heater that runs for the cube assembly. And what happens is you put it in a cubic press. This press is about 9 feet tall and about 40 tons. And it puts about 1 million pounds of pressure per square inch on these diamond crystals. And then the heater runs temperatures up to about 1,300 degrees Celsius. So what we're doing is we're actually replicating how diamond is naturally formed in the earth. It only takes us about 10 minutes. So we make these diamond cubes. What happens during this sintering process, that's what it's called, diamond sintering, the diamond crystals, we have to put tungsten carbide in with the diamond, and in that tungsten carbide there's cobalt. The cobalt will sweep through the diamond crystals, and that provides a catalyst for the diamond crystals to grow together. So the diamonds start to form diamond-to-diamond bonds. So we wanted to kind of walk you through that process because it's diamond to diamond. Am I too loud, guys? Okay, good. The diamond, it's not a coating, it's a solid diamond material. It's called polycrystalline diamond. Most of you are probably familiar with single crystal diamond. This is polycrystalline diamond. It's much tougher. There's no natural cleavage plane on polycrystalline diamond, so it's a tougher material. We've used it for years and years, and we'll talk a little bit more about that. In fact, I want to walk you through the process if we can. Oh, here we go. And maybe, Harris, do you want to walk us through as far as the pressures go and that kind of stuff?
Yeah, so as Mark mentioned, inside that cubic press, we reach the conditions that are to make that diamond sintering, the diamond-to-diamond bonds actually to grow. So it's not diamonds crystals in a matrix or a glue, but rather the diamonds are fused together, so true diamond-to-diamond bonding. You know, we like to do this parallel to help people understand what is 1 million PSI. Well, that's taking the Eiffel Tower upside down and putting it on a 5 inches square area. That'd be the same amount of pressure that exists inside these presses and the conditions to produce the diamond that's going into these nozzles. So.
Awesome. So here, this is called the mic exchange. Did you see that? That was really subtle. So this is our facility. We're based in Utah. We have about 850 employees, and we're making not just, you may think, wow, additive manufacturing has really grown. 850 employees you can support. No, we don't. We have lots of industries that we sell diamond into. In fact, we've been doing it for about 40 years in lots of industries. But this just gives you an idea of kind of our facility and where we make our diamond in Utah. These are some of the industries that some of that diamond's in. We want you to be very comfortable that we know what we're doing when it comes to diamond. We've been making it for other applications that are in some of the hardest rock formations in the world. Some people might say, well, diamond's brittle. Well, yeah, it is, unless you make it a certain way to not make it brittle. If you make polycrystalline diamond, it's going to be much tougher. And here are some of the applications that they're used in, some of the drilling applications and others. All right, so what are the benefits of diamond, specifically for additive manufacturing? This is for the gentleman on the top row that just bought his, because you're gonna love it. Harris is gonna walk us through this. Harris and probably Mike.
Okay, yeah, we've got another animation here that we'll walk through. And so all Diamondback nozzles have a solid diamond tip, as Mark mentioned. It's not a coating, it's not another material with some layer on it, but solid diamond. And so you're going to get the wear resistance of that diamond to print the abrasive filaments, ceramics, metals, and so forth. Right there, we showed that the tip of all the diamonds are polished, so you'll get clean layers, smooth layers coming out of the diamond. On top of that, we have a tapered center bore, which will help to reduce clogging, as well as it's a benefit with retractions and filament changeouts, because the diamond has a low coefficient of friction coupled with this geometry, just produces an ideal condition, again, for those retractions, for filament to not stick and create clogs within the nozzle itself. So we really are leveraging the properties of diamond. It's a natural fit for actually this application, and is why we did it. So I want to highlight here a little bit these material properties that diamond has. And first we'll focus on the thermal properties. The thermal conductivity of diamond is better than any other material that's out there that nozzles are made of currently. It's actually better than copper, better than silver. And so what does that mean in printing? What it means is the tip of the nozzle, the portion that's doing the work, is going to be at the temperature of the system, right? There's not going to be a thermal gradient or a temperature difference from where the thermistor is reading to where the work's actually happening. And on top of that, as the filament's extruded, that energy will replenish. And so you're going to have a consistent output of the filament. The other thermal property we have highlighted here is thermal expansion. Just a unique property of diamond is that it doesn't thermally expand. So if you're running a low temp PLA or a high temp ABS or something even higher, that orifice isn't going to change. You're not going to have variation of the output of the nozzle itself. And then two other properties we wanted to highlight was the coefficient of friction. You've probably heard us mention that a couple times already. But what does that mean with the printing? Well, that means that it's going to have less propensity to stick to the diamond surface. It's going to, again, reduce that propensity of clogging and other issues that you can experience with different nozzle materials. And then the last one that everybody's pretty much aware of is the hardness, right? The diamond is one of the hardest materials on Earth that we're aware of. And so that's really what's going to shine in printing those ceramic filaments or those metal-based filaments, and just a natural fit, again, for this application.
Mike, is there anything you want to add to that? I know from a E3D standpoint, I think you were really interested in the thermal properties as we started that process.
Yeah, thermal properties, and another one with the low coefficient of friction that I guess we haven't really spoke about too much, but when you're even printing like non-abrasive materials, filaments like ABS, they love to just like stay behind inside your nozzle. A lot of nozzles, if you cut them in half, you'll get like this film of ABS that's kind of stayed behind afterwards. And when you change back out to PLA, you've got this like skin of ABS that's built up on the inside, and having a low coefficient of friction in there really helps making sure you can purge that out, things like cold pulls and stuff. It's another great advantage.
I just want to say, I don't know if you can tell like how much we enjoy working together, but I'm sitting here like with a grin on my face listening to Harris's passion about diamonds. It's glorious.
Not just a girl's best friend.
Not just a girl's best friend, Harris says. Okay, so we've shown you a lot of graphs, and we know that graphs are awesome. It's really good. But now you're going to see what happens on a Friday afternoon at our facility in Orem, Utah when we get bored. So this is a test. This is not a scientific test. This is just a test that happens on a Friday afternoon. So we're gonna see if there we go. So we took all of the competitive nozzles and we took them out, and this is a grind test. So it's a destructive test. We were just having fun. There's no scientific value whatsoever, but there's lots of sparks, and that's helpful on a Friday afternoon. So apologies to E3D. we checked. Yeah, we checked with them beforehand. They knew that it wouldn't hold up under this test, but we didn't. We tried to make them part of the test. How's that? So this is our ruby. Yeah, it was.
So we do need to do full disclosure. All of these videos are 2 times, so all of them have been sped up the same amount.
That's right. That's true. That's true. Okay, winner is diamond, right? So we had a good time doing that. So clearly that has no graph, no chart, just a lot of fun on a Friday. Okay, so why did we put it on a nozzle? And I really want to, not just a nozzle, but a Revo nozzle, because we really see, from our perspective, we bring some interesting technology that's really been proven out in lots of industries. But we feel like E3D comes with so many benefits. You guys know E3D, you're familiar with them, you know their technology. The easy change out that a Revo has, they're gonna talk about some of their benefits, but we saw those and really wanted to be part of it. And so that's what's exciting to us. So I'm gonna probably turn this over to Mike, and he can take us through some of the benefits.
So in terms of why, obviously, as Mark kind of alluded to already, there are other Diamondback nozzles already on the market. People love them. People also love Revo, so it's kind of a logical conclusion. Let's bring those two things together. We get all the advantages of our Revo ecosystem at the same time as getting the advantages of the Diamondback nozzles. So I guess the big thing that it's bringing here is that the most extreme filaments, the gnarliest stuff that exists right now. Like over the last 5-6 years, filament has come a long way with the rest of the technology of this industry, and part and parcel of that is that the filament manufacturers are making more and more aggressive filaments, because that's not on purpose, but those materials have other benefits, but as kind of a side effect is that they're particularly difficult and challenging to print. And when you get into metal 3D printing, ceramic filaments are just, you can make a real mess with a ceramic filament. You don't need very much of it to do so, but the diamond nozzles, they really stand up to that. So if you want to do that with your Revo, if you want to unlock the absolute most extreme capability, then this is how you do that. We get the combination then of you can print anything with it, and at the same time you've got the Revo ecosystem. We've got no hot tightening. We've got easy, quick change out between nozzle sizes, between everything. So you can make sure that instead of just choosing what filament am I going to use today, you make sure you use the appropriate nozzle for that as well. And that comes down to size as well as what nozzle construction you're using. So sometimes you might be doing a really small print and you're trying to make almost like a metal injection molding, like MIM, small size, really high detail print, and then the next print you might be doing something huge and you want to use big layers and you want to go to your 0.8 nozzle. So Revo makes it simple for you to change that, I guess, as people already know. What else we got on the slide? Yeah, Karis mentioned this earlier, but the polished tip on the end of the nozzle, that is fantastic in terms of getting real nice, like, top surface quality and things. As well as testing, we've had, like, ourselves, a lot of feedback that I know the guys have had themselves on, just from people using their other nozzles, is, yeah, we love that, and we love the way that our prints look when we use it. So we get that, and the low friction of the diamond innately means that if you do start getting blob monsters on your nozzles, it's nice and easy to clean those off. Do you want to skip on to the next slide? Yeah, I wanted to take a second to talk about some of the things we had to do to make sure that the Diamondback technology would move over to Revo straight away. The hardest part was getting the guys to give us a drawing that had metric dimensions on it. Oh, my goodness. Yeah.
It's true. It did take some time to get the drawing over, but it's interesting. Some of the precision and tolerances that we have in this design, we had to make sure those were right, because going from one system to the next, you had some rounding errors that would come in, and we had to validate that, make sure that those were coming in correctly, so that we maintained the quality that was needed.
I would also say Mike's a stickler. I'm just saying.
It's got to be right. Yeah, so when it comes to normal nozzle wear, I don't know if everyone will be aware, but the primary way that your nozzle will fail if you're doing abrasive printing is the tip flat will recede away. So as it's like rubbing on the top of your print, the abrasive nature of the filament will kind of wear that up. A lot of people think that the orifice hole will just enlarge first. That's actually not what happens normally. Normally you get the tip flat receding into the nozzle. One of the things this can do is mean that over a short print, if you've got the right filament but the wrong nozzle, you can get big step changes in layer height because you're just wearing your nozzle away. So your motion system moves up by your 0.2 millimeters, but you've worn extra off, and that has knock-ons obviously to print quality. We knew that with the diamond insert, we're not going to have that problem. So the question then becomes, okay, well, if you remove the obvious normal point at which the nozzle is going to wear out, what happens next? Like, where does this move the system to, and can the rest of the Revo nozzle stand up to the punishment that you can now put through the tip? The answer is yes, which we were thrilled to find out. But we had to do a lot of work to make sure that everything there was going to be okay. I know there's been times in the past where we've had community discussion about thin wall heat breaks and whether they're going to wear through. We did a lot of validation testing to make sure that we're happy with that, and you can punish your nozzle and everything in a Revo Diamondback is going to be just fine. We did quite a lot of testing with some of the more spicy filaments. We had to reach out to some friends and contacts we had around the industry. We were lucky enough to get hold of some like pre-release filaments that are mostly now on the market, but weren't necessarily when we started developing. And it was like, these are some of the most aggressive things that exist. And we were able to do a lot of print testing with those. And even when we fed that back to the filament manufacturers, they were like, yeah, wow, this is really good. The nozzles we're using at the moment, we're having to change them out like once a week. And now we're not going to have to, so that's great too. I don't know if there's anything else you wanted to add. No, I'll pass it back to you then, Mark.
Thanks, Mike. Oh, do you want to walk through this? You want me to, Claire? Okay, you'll take the last one. We've got just a couple more slides, and we're going to turn you loose. So we just wanted you to give you an idea of what to look for as far as Diamondback E3D, Revo Diamondback looks like. So here's some of the marketing material you'll see. What I mostly want you to see is if you'll look on the very bottom of the Pro Tips card, Revo Diamondback. Oh, no wonder. We're looking at it right here, and now you'll be able to look at it right there. Man. Nothing like talking about something that everybody's like, yeah, sure, right, whatever you say. So this is some of the marketing material that you'll see. Mostly what I want you to see is the very bottom of the Pro Tips card. You'll see the RevoDiamondback.com website. That's where we want you to go to learn more about Revo Diamondback. Also, that's where you'll buy going forward, especially if this is our first entree into international sales, and we're doing it with E3D, so we're really excited about that. But just to give you an idea, we've got a couple more slides, and then we'll turn you loose. The next slide, we just wanted, sometimes you just want to see a video. So we'll watch a video, and then we'll tell you where you can buy them, and we'll thank you for your time and go from there.
Yeah, so that was supposed to be more impressive. There was a really cool soundtrack with it. So, yeah, it was a nozzle spinning. Let's move on. So this will be on general sale late October, so in a few weeks' time. I feel like I say this in product launches a lot. We're ramping up production right now, but we do have the initial launch batch available for sale here as an exclusive offer to East Coast Festival customers. So if you do want to get your hands on one or just chat to E3D or Diamondback about how we got here so far, get any more details you'd like, you can come to Diamondback or E3D stand. We're over that way, right next to each other. And if you want to buy them, we have an exclusive sales partner out here, which is Printed Solid. Come to us, grab the diamonds, and we will walk you over and help you get your first diamond on your Revo nozzle, hot end.
Okay, so we just wanted to check and see if there's any questions before we thank you for your time and applaud you for coming and listening. I know there's a few. Yes, please. Okay, can you?
Yeah, so the question was, do you need the higher power heater cores? So the high power heater cores are for high flow. The reason for the 60-watt heater core is if you move up to some of the largest nozzle sizes, then with certain materials you can start to run into 100% PWM where you're maxing out a 40-watt heater. With the full Diamondback range, you don't need to upgrade to a 60-watt heater core, is my understanding.
But it's worth pointing out that if you've got a 60-watt heater core running, it's absolutely fine. You don't need to swap back to a 40.
Any other questions? Yes, right here, and then we'll go to Grant. Okay, so you want to handle that one?
So diamond is brittle. It's a brittle material, but as we've gone over, the polycrystalline structure does make it tough. This is the same diamond that's being used to drill in the earth, right? If you hit it at the right angle, you may get a fracture, but it's a tough material, and it'll take a beating. And then, Mark, I don't know if you want to talk about the volume.
So in terms of the validation and what we wanted to test with Revo Diamondback, we wanted it to be an equivalent where you can take a standard Revo nozzle, so not a high flow Revo nozzle, but a standard Revo nozzle. We wanted to make that be like, you can change it and you won't see any degradation in performance. So I know if you go to the website, we have this like little lookup table where you can put in your nozzle size and your material, and it will give you what is our sort of estimated this is a flow that we are confident you'll be able to achieve. Flow rates through nozzles is this whole minefield where one customer is running a slightly different temperature, it's a different spool of filament, and they may see 1 or 2 millimeters cubed different. So what E3D did is we put a line in the sand and say, we test it this way, we do it this way, and then we can compare all of our data. So when you look at the table, you might see 1-2 millimeters cubed different to what you're necessarily achieving, but in terms of the relative change between them, that will carry over. And when you go to a Diamondback nozzle, there's no degradation there over a standard, if that makes sense.
Grant, did you have a question? Yeah, the question was, it was Mike's birthday 2 days ago, and we're going to sing him happy birthday. I think that's a great idea, Grant. We support that. So here we go. Happy birthday to you. Happy birthday. Everybody now. Happy birthday, dear Mike. Happy birthday to you. Yay. Yay, Mike. Very good. All right. Well, thanks, everybody. If there's no other questions, thanks for coming. Thanks for listening to us. We look forward to working with you many more years in the future. Thank you. You're welcome. Appreciate you coming. Appreciate I can do that. Yeah, no problem. Like I said, been interested in your product for a while. Yeah, I know. She did. I actually had thought about, I have an XL, so I have an adapter. I was saying, oh, what'd you think of it? That's awesome. I'll take care of it. Oh, yeah. You want to take two? Take two.
you.
If you're interested in our free giveaway at the end of IC3D's presentation, we'll be giving away some carbon fiber polyhex for those that are willing to answer questions. So if you're interested in that, please come to the bleachers for our presentation. Thank you. right, I'm gonna go ahead and get started here, guys.
Also, real quick, if you are here and you have a booth, exhibitor or sponsor booth, and you need filament, if you find a polymaker booth, talk to Nick and ask for a special delivery, and we'll bring it over to your booth. So if you need filament and you're printing here in the event, talk to the polymaker booth and they'll get you a special delivery.
All right, guys, I'm going to go ahead and get started. Okay, my name is Luke. I'm from IC3D. I'm our polymer science materials engineer. I do all of our polymer extrusion. We have a great team and excited to talk to you today. Coming from Columbus, Ohio. Here to talk to you about our new material release called Polyhex, and we're also doing a limited release of carbon fiber filled Polyhex for beta testing right now. So I'll be giving away a couple kilograms of that at the end of this presentation. So you stick around to the end and willing to raise your hand and answer a couple quick questions. I'll be making some key points that you should be able to draw from the presentation to answer those questions. So I'll get to that at the end. I also have on here the future of 3D printing. So for IC3D, the future of 3D printing means a few things, but we're trying to go big. So that means printing bigger things, printing end-use production parts. And we also, that means more material deposition, faster throughput rates. And we're working on that as well, getting into some pellet printing nowadays. And if you guys, at the end of the presentation or later today, if you have a chance, check out the pellet printed chair at our booth. It's actually printed with recycled PETG. And we did a bunch of color blending using our filament colors, so it's really cool. Oh yeah, and then the other piece on this is being more sustainable. So IC3D's mission is to provide sustainable 3D printing manufacturing platform through the vertical integration of materials, machines, and research to empower the future of production manufacturing through the possibilities of 3D printing. And so what that really means is we want to see 3D printing or American 3D printing elevated to a higher level and to basically be on par with traditional manufacturing techniques. So truly production and use parts, that's the goal. So mission-specific things for materials and for government research, which is what actually led to the development of the Polyhex material. So we strive to produce high-quality parts, the highest quality filament, and making that filament easy to print while also being functional and backing that up with data, either done through internal development or through research and R&D with partners. So on the government side of things, that means using and developing new additive manufacturing materials, the processes that surround those materials, as well as developing specific applications to meet the readiness for our nation and for our warfighter. So here are some of IC3D's past and current customers. We are predominantly a B2B type business, so we work a lot with larger companies. We range in, our customers are ranging in different sectors from industries including automotive, aerospace and defense, and even consumer products. And so to support those customers, we have a large 3D print farm. Oh, I'm sorry, guys. I'm driving my presentation over here. Excuse me. You guys are missing all the good stuff. So I'll leave you on this slide for just a second. So these are some of our sponsors, or some of the companies that we work with, excuse me, not our sponsors. These are some of our customers. So as I said, we've got automotive folks, we've got aerospace and defense folks, and then we've got a lot of more consumer-focused products nowadays. And then, so here's our 3D print farm. Oops, I'm going the wrong way. Excuse me. So we've got 52 3D printers. We've got 36 Core XY machines. Those are all desktops. Those are all enclosed. And then we've got the IC3D badged machines, which are the medium class and the large class machines. So we have the Virago 700s. We got 10 of those. Those are 700 millimeter printers. They have a larger Z. And then we've got the large class printers. So we've got 4 E-class printers, which are about a meter cubed in volume. And then we've got the even larger Virago 1200 printers. We've got 2 of those. Those are 1.2 meters cubed. That's the one in the bottom left with the guys standing inside of it. That machine is now outfitted with a pellet head, the Dias Pulsar. And so we're doing not only FFF, but also FGF, which is fused granulate fabrication. There it goes. And so in the past few years, IC3D has gotten involved in a couple of different Department of Defense and government research projects. Most notably our Army SIBR project, which I'm going to talk to you about here today, as well as we were recently awarded a NIST SIBR project to develop quality control centers that would use a distributed 3D printing network to actually meet disaster relief. So this is similar to what happened in COVID-19 when everybody started printing masks and face shields. But basically, we're developing a quality control center network that will be able to have different quality control centers throughout the US. And then, for instance, you guys would be our 3D printers, and you would print parts, send them to this distribution center. We would QC them, and then ship them out to the disaster site from that point. And then, lastly, I have listed on here our CRADA. So we're currently working with Army, the Army Developmental Command Chemical and Biological Center, as well as we're working with the U.S. Marine Corps through the Naval Information Warfare Center. And so we have a cooperative research and development agreement with them, which allows us to share information, projects, and resources to work on collaborative projects. And then also, we recently were included in 2 other proposals, one with the Department of Energy and Ohio University for using coal byproducts in 3D printing. So basically using that to sink carbon in 3D printed objects for construction. And then the other project that's not listed on here, we were just awarded last night, actually, I got notification, an America Makes Project Award, which is on sustainability. So we'll actually be producing recycled PET. So we'll be taking plastic water bottles, getting those ground up, making filament, compounding that with other additives like carbon fiber, glass fiber, and TPU to increase the strength, and then printing those parts for the government, for actually to go on vehicles. I think we're even looking at a quadcopter. All right, so the first project I had listed on there was our Army SIBR project. So we were awarded a phase 1 and a phase 2 with them. SIBR is Small Business Innovation Research Project. So Toby Hanna had a problem. Basically, the Army has a lot of old antiquated equipment, 30 years old, 20, 30 years old, some 50 years old. When those machines go down, they have no way to replace the parts on them because the original equipment manufacturers are gone. And if they are still there, they don't want to, basically they don't want to take the jobs. They're trying to make 5, 10 parts, right? If you're an OEM, I don't want to deal with 5, 10 parts. I want 1,000, 2,000. So the Army is forced to basically use their own internal resources to produce these parts and to fix these things. So in the upper right here is an example part. So the 2 red arrows are pointing to the black overmolding that's on this cable. And so the molds in the bottom left are actually used to produce that overmolding. And what's in the molds there is just a blank, but you would replace that blank with the actual cable end, and then they inject a 2-part epoxy rubber that reacts inside of this mold. Now, traditionally, they're using CNC to do this, so they're using just aluminum molds. So you can imagine that the lead time and the cost to produce a mold to make 5 parts is cost prohibitive. But with 3D printing, we can actually produce a material that can do the same job as the aluminum mold, and we can produce it in a fraction of the time at a fraction of the cost. I think it's like 5 times faster, 5 times cheaper. So that was basically the intent of this project, and this is how Polyhex was born. This material is great for high temperature high compression applications, and it's good for wet environments. So I like to tell people polyhex is a high temperature PETG. It's comparable to polycarbonate in terms of its properties. But some of the applications it can be used in industrial and commercial applications would be tooling, as I already mentioned, vacuum form molding, underhood applications, as well as more of interest to you folks probably in the hobbyist and end consumer products. So you'll see an increased strength and flexibility over PETG with this material. So if you're printing in vase mode or you're printing something thin, this material is going to have a bit more flex to it and stand up to more of a beating. I can show you guys that after the presentation. And then we've also found that we can do this material works well. The neat material works well for high flow and high speed applications. As long as you're able to maintain around 300 C print temperatures, you can push the volumetric flow rate. And then some other applications I have listed here for consumer goods, housewares, those sorts of things. I guess to note on the mechanical properties, basically on par with polycarbonate, but you see that the elongation is higher. I don't know if you guys can see that, but the fourth one there, the elongation of the polyhex is almost double that of the polycarbonate. And so to offset that lack of stiffness, we added carbon fiber to the material. So by adding the carbon fiber, you're increasing the stiffness, and that's how we can bring the properties on par with polycarbonate. Yeah, so as I already mentioned, prints like high temperature PETG. The advantage was with polyhex over polycarbonate, as I've shown here on the right, is that it requires much less of a bed temperature. So we usually run this around 110 C on your bed. So any off-the-shelf desktop printer is probably going to get to 110 if it has a heated bed. If you want to print polycarb and have no warping, you're going to have to get up to like 140, 150 C, right? And then for their nozzle temp, you're going to have to go up to 300 C to print polycarb, possibly a little higher. So with the polyhex, you can basically use an off-the-shelf machine or one with an upgraded head, and you can print polyhex and get near polycarb-like properties. So this material has a glass transition of 110 and an HDT of 100 C. So that means that you can literally put your coffee in it. This material is food grade safe. Now, obviously, the FDM process is not, and neither is the colorant. So that's, take that with a grain of salt, but you can literally put, it doesn't react with chemicals. You can put anything in it. It's not going to react. Maybe besides fuels, that would be the only one that you can put in it. Don't put gasoline in it, I don't think, for extended periods of time. But it'll take heat, and it'll take a beating from chemicals. So last comment on here, I guess two things, actually. Just so you're aware, this material is the same material that's used in Nalgene water bottles. So if you're familiar with how well they hold up and stand up to abuse, being dropped, things like that, this is that same material in filament form. And then lastly on this slide, I have mechanically and chemically recycled feedstocks available. So this material is available in a chemically recycled version. We don't currently offer that filament for sale, but we plan to in the future. So this goes along with our sustainability piece. And we've recently been in contact with a couple suppliers for a mechanically recycled version of this feedstock. So let's address, some people would call it the elephant in the room. I don't know if I would call it the elephant, but recycling, right? Let's talk about recycling. We're doing a lot of 3D printing. We're all using a lot of plastic. Everybody wants to be more environmentally conscious. We all want to see more things being recycled, right? So this is a chart showing what's happened with recycling in the US since, the early, I think it's like 1950s or 60s. But notably, two key points in that timeline. In 2008, we were at 8% of total plastic production actually being recycled. In 2018, it hadn't grown any. It was still 8%. That's not good. You can see that plastic production in that same amount of time went up tremendously. So the gray thing underneath this chart, that's what's being landfilled currently. So we have a major problem, right? So that's why we're trying to move towards more sustainable materials. We're trying to push for using recycled materials. And obviously, if you guys are familiar with, if you're familiar with IC3D, you're probably familiar with our recycled PET-G. So that is now our #1 selling product, and the recycled PET-G has just taken off. So we are planning to, in the future, actually introduce an all recycled lineup for all our materials. So that would include ABS, that would include recycled polyhex, that would include, you know, we now have a UV PET-G, we have a matte RPET-G. So all those materials will be recycled. Just showing here some pictures. The bottom left is our manufacturing lines for where we do all our polymer extrusion. The top left is the grinder that we use to grind up scrap parts, whether that's failed prints or out-of-spec filament. Top right showing what that grind looks like when it comes out of the grinder. We'll then sift that material to separate out long strands as well as remove small powder-like substances. And then in the bottom right, the piece of equipment on the top of the machine, that's a doser or a gravimetric mixer. And it can actually mix virgin, recycled, it can mix colors, it can mix additives, and basically it allows you to produce your formulas quickly and easily. So IC3D is moving towards a more recycled supply chain, and we even offer a spool return program for our larger spools. So talking about using recycled materials, we are beginning to pellet print furniture, planters. If you go to our booth, as I mentioned at the beginning of the presentation, you can see one of the 3D printed chairs we have here. And this is just a generic picture, but we are using the Dies Pulsar on our V1200 to do that. And then on the left here, we have a dryer shown. So as you guys are probably aware, filament gets wet. Same thing, you have the same issues with the regrind. Everything has to be dried, right? So basically the process for pellet printing is dry the regrind, add your color, run it through your pellet printer like you would any other print, and voila, you've got your end-use production parts. And so what we've started doing is we're incorporating a matte additive in our pellet head printing process, and that matte additive allows us to produce large parts that hide the layer lines well. And so we're able to offer products that don't need to be post-processed or post-machined. You can just print the final end-use part. So we believe that these capabilities are going to dramatically change the future of 3D printing. Okay, lastly, I'd be remiss if I didn't mention it, but we are running our 6th annual Toys for Tots campaign. We are no longer signing up elves at this point in time, but if you would like to become a sponsor, you can go to the link shown at the bottom here or visit our booth where we have a QR code that you can scan. Basically, Toys for Tots was started by our COO, Matt, and the idea started from printing, I think we printed like 150 toys the first year. And now we're up to 85,000 is our goal, and we're already well on our way to hitting that goal. Also, I'll just say, IC3D supports this effort by basically sending recycled PET-G out to all the printer elves. So the printer elves are you guys, and you guys are making all these parts. So thank you for helping bring this together. All right, guys, that's all I've got for you. I'll take questions at this time if there are any. Otherwise, I'll go into the giveaway. Anything? Yeah. Right. Okay, so the question was, if we use recycled feedstocks, how do you ensure quality and consistency, right? Yes. Yeah, so we use both. So we use a mixture. So if we're making black recycled PET-G, we can use our own in-house regrind for that because once the material is colored, if you're using a mechanical recycling technique, it's very hard to go backwards. Like I can't take the color out of it, right? So I can only go darker or to a higher color saturation. So when we're using our in-house regrind, that would be, that's what's in our black arpeggi. If you are getting just like cherry, let's say, or blue raz arpeggi, right? Those colors are produced with an outside sourced recycled feedstock, if that answers your question. And recycled materials are harder to come by. We have to rely on our broker network to basically source those materials. And lot numbers and traceability is still an issue within the recycled materials. So in terms of quality for filament production, that looks like basically gauge checking all of our filament. So everything we make is now run through a gauge. So your main issue with recycled materials is going to be contamination and small particles and contaminants coming through your filament. Obviously, the material will tend to flow around that object that's in there. So if you have a small particle like a piece of dust or a hair or a piece of cardboard, the plastic will actually form around that piece of cardboard and turn into kind of a bulge. And so we actually catch those in our process. So anything that comes through as far as a contaminant is basically removed before sale. And then we would grind that up again and recycle it again. The polyhex, I actually don't believe it is UV resistant technically. So there is a UV PET G that we offer. We've discussed doing a UV polyhex, so we can add UV additive to polyhex to give it those mechanical properties. But the issue is demand right now. So if we see a need for it or we see the demand increase, then we could absolutely do a UV stable polyhex. That said, I mean, if you've done anything with PET G for outdoor printing, you know those parts last multiple years outside without an issue. Polyhex is gonna act similarly, if not better. Basically, polyhex has superior properties across the board compared to PET G. It will have similar string if it's wet. So make sure your stuff's dry, and then print cold. So I've got this. This was printed at 275C. It's got more of a matte surface finish. You can do props. I was showing everybody. This will give you a bit more flex without breakage than PET G will. So it's got a good amount of flex to it. This is the neat polyhex, so unfilled, no carbon in it. But I'm actually hoping to give away a couple kilograms of the carbon fiber polyhex now. So I've got two 10% and a 15%. So you guys can pick which one you want. And if you don't like it, come talk to me afterwards and we'll swap it out for something that works better for you. You can also get some of the the unfilled polyhex if you prefer, if you don't want the carbon filled. But I thought it'd be fun to give away some of the carbon fiber stuff since we're only selling it this weekend. So, all right, couple questions. These questions are from today's presentation. So I'll start off with an easy one. Well, I think it's easy. So how many years has IC3D been running the Toys for Tots campaign? I just said it. Did anybody catch it? Yep, 6 years. Come get one. All right, next question is, who was the military branch that we worked with to develop this material? Yep, Army. And then the last question is, this is a hard one. I'll make it a little bit easier on you. What bed temp do you need to print polyhex? What's the recommended bed temp? Did anybody catch that one? 110. Yep, 110. All right. Thank you, guys.
Hello. Hey guys. Hi. Okay, we're gonna start now. I'm the presenter for today. My name is Mark Pan, and I'm gonna talk to you about our journey to make the new printer Magneto X. And so this is our agenda. So we're gonna do a quick introduction about Pure Poly and myself. I'm gonna talk a little bit about the core feature of Magneto X and how we started. The challenges we deal with during developing this new linear model system. I'm sorry. Some of the things we have to, some of the results we did, and also how open source kind of be a big part of our development, as well as what we are going to do to kind of put it back to the community. So that's kind of today's talk. First of all, my name is Mark Pan. I'm a Taiwanese American. And I'm the founder of both Pure Poly and Tech. Pure Poly is usually known for making resin printer, UV resin printer, and Tech is known for making UV resin 3D printing materials. So this was generally what we know. And I've been coming to MERV or RepRap event a lot for the last 6 years. So this was me 6 years ago at MERV 2017. We were launching Moai laser SLA printer back then. I was building the kit right there. You can see Chuck Filament Friday at the back, and probably Mitch somewhere at the back. And then you go fast forward. This is 2019 here at Earth. I was launching the new Phenom resin printer. You can see it's actually right over there. And we had a great launch that year. I really had a good memory of this place, especially with Maryland and the location and the people here. And this is, so I'm gonna start talking about a little bit of the Magneto X, how we started. And you hear the pictures that this is the Trident I built with a lot of help from my engineer this year, but we also built a couple other follow-on ones. So the project, the Magneto project actually started in summer of 2022. The lockdown is still kind of going on in Shenzhen, China, where my engineering team is based at. And so one day, our engineering lab was locked down for 21 days straight. Like they didn't let us out. There was no bed. It was just, a couple of sofa and a lot of computers. So we were locked down. There's nothing to do, and we did the things that a lot of you probably did, which is watch a lot of YouTube videos, including a lot of Voron-related videos. Some of the contents that were actually made by people sitting here. So that's kind of how it started. And the thing about that lockdown is that you couldn't get out. They'll give you food, so you don't have to worry about anything. But you still could order parts from Alibaba. So we started ordering a lot of parts from Alibaba. It was like one-day shipping. It's really local. So we started building Voron printers at that time. And then we thought, hey, this is really fun. And we say, hey, what can we do to make the experience better? So that's kind of the beginning of the Magneto project, where we say, what about if we put servo motors in? What about if we're putting linear motors in? So, and we kind of went from that. And as I go down to the feature list, you can see a lot of Voron influences on it. So this is the Magneto X. You can see it at our booth right over there, 2 rows down. So the key feature for this printer is the magnetic linear motor. And that's just, there's no belts, no wheels on there. It doesn't use step motor. And the way it designs that, it has a lot of lower friction, so you can get better data in the input shaping. You can print faster, and also a lot less maintenance in the long run. The other one is the lens extruders, where because if you want to print high speed, the other big factor is that you need an extruder that can push the filament fast. And so we came out with our own extruders, but also using standard E3D V6 volcano nozzle. And the idea for that was that our user can replace the nozzle anywhere they are. Like they probably have a lot of volcano nozzles in their closet anyway. So if something goes down, you got replacement parts. You don't need to order like a proprietary parts. That was kind of part of the design concept as well. It has 4 independent Z-axis. So we kind of got this kind of from the some of the Voron projects as well. And then, of course, the low cell sensoring. That one, we saw some of the things were doing that, so we kind of put that in the extruders. And as well, I'm going to talk a little bit more in depth later on about the Clipper firmware, how it kind of impacts the development, as well as the Orca slicer, which both we are the sponsor of both projects. So, so what were the hurdles? What were the problems? So once we had the idea of putting linear motors in a printer, we started talking to a lot of teams, a lot of users. Like, hey, what do you think of the idea? But we didn't want to give out the secret sauce, so we didn't say we were making printers with linear motors. We were telling them we were making printers with servo motors, with ball screws, because it's also expensive, and it also has a higher precision, and we kind of want to get some feedback. And the feedbacks we got are generally, it's too expensive. It's an overkill, basically. You're running a 0.4 millimeter nozzle, and you will never be able to use the 1 micron precision on a 0.4 millimeter nozzle. At least that was the line of thinking. And then also, just on the back end side, for product development side, there's really no existing supply chain for this kind of motor. There are suppliers for linear motors, but those are for heavy CNC machines. Those are very expensive, and there's no way you could actually put it in a regular desktop printer. And then also there's no reference trial. Like, we can't really look up another project and say, hey, somebody else did it, and we're gonna get some ideas and modify it for it. But we decided to go ahead because some of the users told us that, hey, if there's encoders that gives a true closed loop feedback on it, this is going to be very useful. And the other idea was that, sure, the extrusion system is not as precise, but if we build a motion system that's more precise than what we got right now, then that would be a platform for the extrusion specialists to build a better, more precise extrusion systems down the road, so now they have something to start with. So that's kind of what we got us going. And so it was a year-long development process. And what we learned was that you actually have to build a printer to make the motor, because it's kind of customized for that printer. So it's kind of like a chicken, like an egg and chicken kind of situation. And you have to kind of build a printer first, build a motor first, and then build a motor for it. And then you realize, hey, we made some design mistakes. Then we have to rebuild the motor again, and then build another printer. And with this is about 5 times. The 5th generation engineering sample is actually at the table. That's the latest version. And then we're ready to go into the production. Some of the things we did was we kind of take reference like, okay, let's say if you have a really nice features on a race car, but you want to put it in a regular everyday driver. How do you do that? Like it might not fit in a regular car. It might be too expensive to fit in a regular car. So there are things we have to do to, okay, maybe we don't need all that performance of an industrial linear motor. We can scale it down a little bit, but make it a little bit more cost effective so more people can actually use it in the printer. So those are kind of the things we have to deal with. And also, I would say that the firmware and the slicer really make the process a lot simpler. And I'll get into that after this. So one thing I want to talk about is Clipper. So I think we're not the only printer company that's actually using a Clipper to develop. They're using Clipper firmware to develop the printer. And the reason for that is because I feel this is a good idea of a virtualization of the hardware. So when you're making a printer now, you don't really need to get into that low-level hardware talks to software kind of thing. You can do it more on a higher level perspective, and that simplifies things a lot. So this was allow us to make experiment with new motion system a lot easier, and this is really instrumental to speed up the development. I think without Clipper firmware, we will probably take us another year at least to get to this point. And we are a proud sponsor of Clipper firmware. So our plan is to, now that we have this driver system for linear motor, we like to kind of feedback the motor motion system data back to the Clipper so that you can actually do even more advanced calibration with how the things are moving. So that's kind of the way, not just being a sponsor, but also putting back into the community. The next is Orca Slicer. I don't know if any of you guys are using Orca Slicer. I really liked it. I talked to, I don't know if he tells so he goes by Soft Fever. Nobody really knows his first name, but if you send him like a free coffee, you can see his name. He's based in Singapore. And the integration between Orca Slicer and Clipper really makes things a lot easier in terms of for developer too. This gives us a really nice user experience that we also can save us a lot of time on development too. So we are also a sponsor for this project. And we plan to contribute back to this project by putting in AI detection, local AI detection in the slicer. And this is something that he's really interested as well, so that you don't really have to go to the cloud. You just install a slicer, maybe load the model, and you can do the failure detection that way. Oh, this is the older one. So I'm on top of one design, and then I'm gonna go back to what's next. So we got a lot of ideas inspired by Voron design. And our electronics, if you look at it, it's actually running on Orange Pi 02. It's using standard Big-Tree Octopus board. And a lot of setup is related to Voron design where you could fix it pretty easily, and it allows users to do some experimentation because everyone have a different need and also different, they have a different need and also have a different printing environment. So these are all the things like we got from Voron design team. And our planned contribution back to the Voron is that some things like low cell sensor, we're probably going to set up so that it will be something that the Voron users can also adapt easily to their printer as well. So things like that, we will want to put it back to the community. And finally, what's next for us? We're going to hit production next month, end of next month, and we'll try to go bigger and faster. And hopefully, we can do multicolor by next year too. Thank you so much. We'll be at the table, so if you have any questions, feel free to come by. And I think I can take maybe one question. You guys have one question? Oh. I haven't decided, but I do have an extra USB port on the outside, so it makes MMU pretty, like Enraged Rabbit would be pretty easy to do. All right, cool. Thank you, guys.
Did you hear? Hey guys. So yeah, I'm Sam. I'm Sam from the Counterpulsar shop, and today we are here to present to you the Prometheus MSLA project, the first open source resin 3D printers. So before entering into the details, I wanted to present myself and my little business I started a few years ago with my girlfriend. Melissa and I are are first of all artists, makers, and DIYers. You know the saying, "I can make that," but yeah, it's us. We met at work where I'm working as an electronic technician. The weird guy at the back that makes your project works, but yeah, that's me. We started the Counterpulsar Shop company on top of our YouTube channel to bring our idea to life and share them with people. We had FDM 3D printers at home for quite some time, but resin printer was starting to interest us because they were more and more accessible. The problem was at the time, everything was too small for our needs. It's understandable because they were usually made with phone or tablet screens. The only big size that was available, it was the pure polyphenol that was too expensive for us. It was about $3,000 Canadian. So remember the saying, yeah, we can make that, but that's that's what we wanted to do. If we can assemble a Core XY printer, we can certainly make a single-axis printer. It should be simple, right? So, and for sure, it will be cheaper because everything, no research and development is cheap. After all, it's my first resin 3D printers. After research on the internet, I wasn't able to really find project like the one I wanted. I have been able to find bits here and there, but not complete projects. On top of that, Shido system were starting to be more and more annoying with their lock system, and realized that pretty much all the MSLA printer we know was having almost the same components, screen, boards, and LED source. So manufacturer was pretty much only make the frame. So during the year 2020, the Prometheus MSLA was born. So this is what I call the V0, the prototype. Pretty much everything on that machine was changed and or improved. Since the first failed print part at 7:28 p.m. on a frozen chicken nugget box, the first real successful print, and now we have learned so much. The UV source, printer structure, and everything that makes the machine runs. I really wanted to bring a printer to the public that could be the future Voron kit of resin printers at an affordable price. So at the end of the year 2021, we launched our Kickstarter for the machine. Unfortunately, it wasn't successful. We learned a lot of marketing, and oh boy, there's so much than we thought. With what happened with the COVID, I think it's better like that. I don't think we will have been able to do well with all the shortage. This gives us the opportunity to work more on the concept and give us time. During the campaign, we met so much people. The community was growing fast and didn't stop since then. Pretty much everybody we have, pretty much every day we have new members into our Discord server. With all those new people, we found new people to put in our team that has a lot of crazy idea like me. I didn't put everyone, but for the main team is my girlfriend and I. My girlfriend is producing all the boards and makes everything pretty. There's Paul. Paul is not here today. He's from Germany, and it helps with board conception and helps Ada with code and all. And Ada right here, that is our talented programmer, software engineer. There's there's a lot of other people that has contributed a way or another to the project. We didn't stop the iteration and enumeration on the board. We now have a board that is very versatile. It runs Clipper, yeah, for resin Clipper. Now, so adding and modifying stuff makes it easy. We have all sort of ideas, mods like pumps, heaters, sensors, especially the first sensor we have in demo to our booth. Multiple lead screws, arm, and more. Everything is done in our workshop. My girlfriend makes pretty much all the assembly, and she loves it. So if you want to give her more work, you know what to do. Finally, the V1 of the Prometheus is here. The fully customizable and fully open printer is here. All the documentation is or will be online. You have access to all the CADs, schematic, and codes on our GitHub. You can you can fully source yourself the Prometheus or order from one of our partners. Now we have DLL PDF. He has a booth here that offers partial kit of the Prometheus. So basically, all the thing harder to source or make, he has it. Then we have Gingerbread 3D in Germany that will launch very soon complete kits of the Prometheus. So I will leave you with Ada, so she can show you the last step to be considered as fully open, the main OS of the machine. The fully open source resin printer, the fully open source OS Odyssey.
All right, can you all hear me through this? Is it good? Okay, just making sure. Yeah, so shortly into the project, Sam realized that to be a fully open source machine, we would need to find an open source software solution. That's not something that exists presently for resin printers. There's no Marlin, there's no Clipper, there's no all-in-one open source solution for running your printer. Currently, we use NanoDLP, which is a free-to-use closed source software, but I've started work on our open source alternative, Odyssey, which runs Rust for the back end and uses a Flutter user interface to provide a touchscreen interface on the front of the machine, as well as a web interface available on your phone, your computer, your tablet, or whatever. Yeah, it's still a work in progress, but you can find all of the source code on GitHub for it, and you can try it out, give it a run, or contribute yourself. It currently supports sliced models from Prusa Slicer, but we're working to integrate additional slicers into that. If you're interested in getting involved, there was supposed to be a QR code there. Come see our booth. We've got little PCB coins with the QR code instead.
Yeah, so that was it. Thank you, everyone. So you can see the Prometheus on our booth and talk with us.
Ladies and gentlemen, please make your way to the build platform to listen to Tony from Duet speak about open source and the community.
good until after this, thank you. Hello. Fair enough. Hi, everybody. Have I got the mic in the right place? Do I have to lean forward, or can you hear me okay when I'm stood up like this? All right, well, good afternoon, East Coast RepRap Festival. My name's Tony Locke. I'm here at the festival on behalf of Duet 3D, but I'm actually here on the stage as a member of this open source hardware community. I joined the community 13 plus years ago when I started building RepRaps. And what a fantastic presentation to follow. Thanks, Sam. He's sort of pioneering more open source hardware. And this talk has been brewing for quite a long time. If you've known me for the last 1 to 10 years, you'll know that I'm pretty passionate about open source and pretty passionate about this community. And I've probably bored you to death in some bar about some aspects of this talk. And why did I decide to do a talk today? Well, it's in response really to Joe's blog post from back in March, where he highlights quite a few issues that we have in the community and highlights these problems and wants us to start a discussion about how to deal with them. Now I'm going to touch on a lot of things. I'm not a lawyer, and I'm going to talk about patent law and licenses and all sorts of stuff like that. But thankfully, they've been a range of experts and really knowledgeable people that have also replied to Joe's blog post. And I'm going to draw on a lot of those sources in what I'm going to talk about. And I'm really grateful for everybody I'm grateful for Joe for starting this conversation, and I'm grateful for everybody else who's already replied and contributed to it. And I see this is a community of friends, and I want my talk to be taken as that, as part of a continuation of this conversation, and not as like, this is the law according to Tony or according to Duet 3D. So if we're going to talk about open source hardware, we need to have a common understanding, and I'm going to use the Open Source Hardware Association's understanding of that. Open source hardware comes from open source software, originally, the ideas behind it, and they in turn come from free software. And when free software came into existence as an idea back in the early 1980s, the world we lived in then was a much more open, a much more free world than the world that we live in now. We now have things like DRM that didn't exist back in the 1980s. And so for me, open source was important way back when it first came into existence, but it's even more important and even more pressing now. But it's more than licenses and law. It's about the community. Why do we have open source in the first place? Well, I really like Taya's take on this, and they talk about empowerment. And I think that is so super important. It's about empowering individuals to build and to open stuff. And when you empower these individuals and we start sharing things, we automatically start building a community. Even us really kind of introverted people want to share what we're doing and what we're building, and that then comes with a community. Right, so we're going to talk about this very briefly because, as I said, I'm not a lawyer, but we need a little bit of background. And we'll talk about law first. And we've got a number of laws that impact on this space. We've got copyright law, and copyright law is best understood. It's been around for centuries, but it's best understood as an author's monopoly. I mean, it lasts for a long time. It comes into existence whenever you render something on paper or record it, and it lasts thanks to Disney and other lobbyists 75 plus years after people's death. We also need to talk about patents, and patents can probably best be understood as an inventor's monopoly. They're granted by a government as a kind of one-for-one exchange for showing how you made the thing. It's sort of the very, very slow, very terrible process that predates open source, where you show how you do the thing, but you get to do it and nobody else can do it for like 20 plus years. I put trademarks up there because somebody asked me about them if I didn't mention them, but I'm not really going to talk much more about them. They're more for consumer protection. And finally, we need to talk about DRM, because while thankfully it doesn't impact us that much in this community yet, if we look across more broadly at what happens in 2D printing or tractors or pretty much any other aspect of hardware, DRM is having a really big influence and a really big restriction in those areas. And I mean, what is DRM? I mean, it's bullshit. It's business model protection, if anything. You notice that I haven't used the words IP or intellectual property up until this point. And that's because IP is not a law. IP is a business legal term that's been used to sweep all of these things together, all of these monopolies, and try and make them into property. Cory Doctorow is an activist and an author, and I really like his take on what IP is. It's just a way of a company building a moat and controlling the conduct of their competitors, their customers, and their critics. And if we want to look at what DRM is, this is a great way to think about it. Like anytime you buy something and you own something, but somebody else has put a lock on it that you can't open, that's basically what DRM is. And they're not trying to do it for your benefit, I promise you. So what does open source do as a sort of reaction to these restrictions? Well, most of what we do within a licensing space is done, and it's hung off copyright law. It basically tries to use the restrictions of copyright law, and in the case of GPL, turn them on their head. So rather than being copyright, copyleft. Use the legal requirements to license stuff to force people to maintain those licenses and keep things open. You also have more permissive licenses like MIT and Apache, which don't carry forward those restrictions on future use. You've got the Creative Commons, which I like Michael Weinberg's sort of description of a choose-your-own-adventure for those. And not all of the Creative Commons licenses are open. They have non-commercial versions, which aren't open, but the majority of them are open licenses. As an aside, if you haven't watched the movie The Internet's Own Boy about Aaron Swartz, he was one of the people who brought us Creative Commons. It's a really good watch. I really recommend watching that. And I'm not even going to say, like, open source is a reaction to things like DRM. So now let's talk about Joe's post. He wanted us to have a conversation. We've got a bit of background. This is my summary of the issues that he brought up in that post. Now, might not be completely accurate, but this is my summary of the... He's raised some points as well, but that should be points. Companies are not playing by the rules. They're not giving attribution where attribution is required. There's no reciprocation when we should be reciprocal. And there's outright cloning of things going on. The other big area that's a big concern is patenting, especially patenting of existing open source designs. And the third point that he brings out is that specifically that the GPL as a license is not fit for purpose for hardware. And these points are echoed by other people in the community. This is not just sort of Pruse's take on this. If we look at, for example, Claire's talk for last year here at Earth, she highlighted how the growth of patents is restricting all of our free creative space to do different things. We take this example, the hell that Tobin's been through with a hang printer that was recently resolved. This is a US institute patenting something that has basically been Tobin's life work in open source hardware. We look at something more recent. I mean, I just picked this off Twitter a couple of weeks ago. Bill with the 3D Chameleon. They've been patents applied for in other countries that clearly post-date Bill's work and the work that's from people way back from Adrian, who was doing stuff around this. So we can agree there's a problem. Where maybe I slightly disagree is that it's a completely new problem. And where I also disagree is that is a new license going to help? Michael Weinberg's reply, he's one of the lawyers that worked with CERN to write the OHL. His reply about the newness of the problem, I sort of agree and disagree with him. He's right. He invokes the ghost of MakerBot, which we all love to invoke, to point out that this is not a new problem. But I think in some areas, especially when we're talking about the patents, it is a growing, really importantly growing problem. We look at that exponential curve, and I've got another graph later where it's even more exponential. Our free creative space is being restricted. Okay, so we've definitely got a problem. Joe proposes we might need a new license as a solution. Because we can't read all of that in the time and the font's too small, I've distilled broadly my interpretation of his points for the license that he's proposing. The first thing is it enforces attribution, which, to be fair, a lot of the licenses that we use already enforce attribution. It bans commercial clones. We allow upgrades and mods. We say that consumables must be licensed. And the license, it's got to get out. It ends if a product becomes obsolete or if the licenser stops activity for any reason. Now, I would say that before we talk about a new license, what are we doing to enforce existing licenses? If we take something like Prusa, that's licensed under the GPL. That license as software can be enforced. It would be difficult. It would be expensive, but it could potentially be done. But often, the things that we disagree with that's happening in this community, they're not necessarily going against things that could be dealt with through the legal system. They're not necessarily illegal, but what they are is they're blisteringly against our community norms. And that is something that we need to talk about further and think about as a community. How do we address people or companies more like it that are breaking our norms? This is difficult. I don't have the answer, but this is really, really important. If you run a forum and somebody's being a dick and trolling, you kick them off. How do we do that as a community, and a community of individuals as well as businesses? Another point about the license is that licenses don't stop clones. I mean, Taya's point is really obvious here, and even Apple gets cloned, and clearly they're not open sourcing anything. I would also point out that if you're doing an open source project and you're not being cloned, you haven't made it yet. Like, really, to be fair, you're not being noticed enough if somebody's not cloning your stuff if it's open source. We've been cloned. Yes. The next point, and I think this is kind of the core of the problem with the patents, is licenses are not going to stop people doing bad patents in other countries. If you're trying to license or trying to patent a polar printer, like Nero found this and tweeted about it, then a license is not going to stop you, because you can go to the RepRap blog and look at the history and realize that we've been doing polar printers since 2010. And the person putting that, or the company putting that patent in doesn't care about that, and I don't think a license would change it. And the third point I want to address is the GPL not being fit for purpose. Now here I totally agree, it's not fit for purpose for hardware, but it is fit for purpose for software. And it's been proven in court. We can look back to like 2017, there are many 2007. There are many examples. In this case, BusyBox getting judgments against people who are infringing its GPL licensed software and getting the code opened up and getting damages and payment against that. But it's not only fit for purpose for software. If we look at hardware, well, we license stuff under the open hardware license. It's more suitable for hardware. It'll be interesting to see whether there'll ever be an example of enforcement under the OHL. Because really, these licenses only come into their own when they're enforced and being seen to have teeth. But for larger projects, it's actually going to be a mix of licenses. I mean, if we look at a Duet ecosystem, for example, the control boards, the electronic design are licensed under the open hardware license. The firmware that runs on that is licensed under the GPL. Our object model, which we can use to pass lots of information about the machine, that is licensed under the LGPL, because we want to allow commercial companies to integrate with our boards without having to open source their whole tool chain. We keep going up. Some of the software is licensed on under the GPL. We then look at our documentation. That's Creative Commons by SA. We also do custom hardware designs for companies, and those aren't open at all. Those are closed source. So you don't need to have a one license fixes all the problems solution to this. There's a mix of licenses out there. Now, I'm going to talk about what we can do as a community in a minute, but I want to talk about a little bit what we can do as businesses, because as businesses as part of this community. And none of this is easy. But one option we can look at is patent pledges and patent pools. This has worked in other industries. of course, to do that, you first need to have some patents. And if we look around the community, there's not many businesses that have that. But that would be one option. We could look and explore group legal action. Once again, this is really difficult, really expensive, and I think unlikely to happen. But we haven't really had that conversation about how do we coordinate as open source companies to do this stuff. And then a question mark, because really, I don't think this is going to be solved by businesses. This is, if anybody knows Philip Tyrone, he's been working in this industry documenting open source hardware for well over a decade. And this is lovely, but it's super idealistic. I think if we all did this as companies, it'd be a lovely world to work in, but it isn't the world that we live in. But at least we can look at working towards that direction and collaborating more. But that's just businesses. Businesses are part of the community, and the community is made up of individuals. So what can we do as individuals and as a community of individuals to move forward? Well, the first thing we can do is challenge patents. Now, this is difficult, but Tobin did it. He successfully limited the hang printer patent to irrelevance. Now, he didn't do it by himself. He did a crowdfunder, and he got an amazing lawyer, McCoy Smith, who's a trailblazer for open source, to work with him. But he did it, and I really recommend reading his blog post on how he did it, because it is a masterclass on how to do this, and has so much prior art and examples of that. Great success, yay. We can also submit prior art. If we look at this graph, that's not even open source patents, that's 3D printing patents in general. I guarantee that some of those patents are not truly valid, but they've been granted because nobody's working hard enough to invalidate them before they're granted. Prof. Pierce's reply to Prusa, he had 3 replies on 3dprint.com, he highlights this. It would be great to have us as a community to build a system to automate the submission of prior art to prevent these patents from being issued in the first place. We can all generate prior art, and we can publish it, blog about it, get Hackaday to write about it, because as much as we like to have conversations on Discord and video streams, that's really hard to submit as prior art. We need to publish it. And it can be as crazy ideas. I mean, back in 2019, Adrian was here talking about a 3D printer that doesn't exist and may not exist for a really long time. But by documenting his electro gel thing, it means that that's very much unlikely to ever be patented, or more difficult to be patented. Once again, this is underlined by Prof. Pierce. And I would say for influencers and people with sort of eyeballs, you can really help with this as well. So you can highlight some of these cool and crazy projects that people are doing, rather than just reviewing the latest Omerod derivative. And also, please use open tools if you can, really helps. Now, don't laugh, we can change the law. Maybe not by ourselves, but we can lobby, and we can join lobbying groups. Join the EFF. They've been fighting to turn over DRM for a decade, well, almost a decade. Support right-to-repair movements. Recognize that we're part of a common, broader goal to not have our freedoms restricted. And this is working. That's the really cool thing. This is working. It's slow, but it's working. Hack stuff. If you want to, hack it. You know, we've got people on our forums breaking Stratasys machines and stopping them turning into e-waste. I mean, I don't know whether Mitch, he's here, but I don't think he's in the audience. You know, don't worry, I'm sure people are working on it. So I'm going to close up now. I'm nearly at the end of what I have to say. I'll be available to chat and comments. I think I'm running a little bit out of time, so I'm not going to have time for questions. But come and find me afterwards and tell me what you think. If you want the long and detailed version of this rant, then find me in the bar later. I'm going to put a QR code up, which has got links to all of this information that I've referenced in a link tree. So if you want to do some background reading and kind of get up to speed with a lot of this, then I recommend that. I do have one more point before I sort of finish, and that really is don't give up hope. We need to challenge the narrative that OS is dead. We need to challenge the narrative that open source hardware is over, that open source hardware is a bad business model. I walked around the show today, I walked around Murph, I look at our forums, And there are so many cool open source hardware projects here. There are far more open source printers out there than there are closed. This is a community. It's not a business model. And it's only dead when the people who make it leave. I hope you stick around. Thank you very much. It's okay. I'll leave it at that. Thank you.
Ladies and gentlemen, coming up in about 5 minutes, I believe we have Sven from Bloxbury on the stage. If you want to join him there for an awesome talk, Sven from Bloxbury, about 5 minutes.
Okay. Whoa. I'm going to take a selfie, so smile. Very nice, very nice. Well, hi. So, apparently I talk a lot. This always comes as a revelation to me. And I forget that I talk a lot. So when I was asked, would I like to talk here? I thought, oh, I'm not really much of a talker, but why not? That sounds like fun. And I thought, what is it that I could just ramble about that people may or may not want to hear about? And I figured I'm just going to do some self-therapy and just talk about the things that keep me doing design all day, every day, awake, asleep, and so on. Because this stuff really does overtake your life after a while. So it says constraints and creativity, but really this is just like, why do I like designing for 3D printing? So 3D printing is pretty much magic. It still feels like magic even after all these years. So the idea that we can just create something virtually and have it realized in physical form is just, this amazing thing. But when we first get into this stuff, we realize pretty quickly that there are some limitations. It doesn't just magically go, ta-da, and you've got the thing. So there's some reality checks that we run into. And some of them are pretty reasonable, like big overhangs, you can't do that. And you realize, yes, gravity is a thing, and you need to respect that. And so very quickly you realize, okay, maybe I won't try to design things like that. But then you think, oh, I'm going to make, I don't know if you're like me, but things like electronics enclosures, and you think, I'm going to make something for my Arduino or my Raspberry Pi, and I'll just make a box, and I'll put a lid, and then you realize that, no, you can't do that either, because there's these holes that will sag. Okay, things are better these days. But, you suddenly realize that these things that seem like really reasonable requests just don't work in reality. So very quickly, just the magic loses some of its edge, and it becomes a little antagonistic. And so you work around it. Now, there are plenty of ways to work around it. I'm pretty sure that these were the things that I did initially. There's supports, which I still say no to supports. I might be wrong in that one, but instead, things like clamshells. And so we start making assemblies and things that fit together just so that the magic still exists, even though things don't work out quite as magically as we might like. But there are plenty of other things that very quickly start to trip us up. Oh, like the fact that orientation actually matters. So suddenly those long, thin things that you print sticking straight up start to break. And things that need strength, need to be lying down. And so we start finding ways around that. So things like threads that have a flat base, things that have deviated slightly from the dream, but still manage to achieve what we're trying to do. But it's this antagonistic relationship that we have, even when it's still, exciting stuff, there's this forever battle with like, how can I achieve what it is I'm trying to do? I've got this idea in my head based on real life, and I want it to work out of a printer as well. And tall things fall over. See, this thing was meant to be, this was a few years ago, but that was meant to be a relatively straightforward print. But I hadn't appreciated at the time that printers wobble, and things wobble, and they fall over, and all of this model is made up of lots of tall, thin things, and if it wobbles, things stick together. Things fall over, and it fails, and in an age of slow printers, that would fail like 30 hours in, and so on. So, yet another thing that, you realize that the reality doesn't quite match up to the dream. And there's plenty of other things. I drew them out here. I wish I'd found photos of when I used to get my Build-Tac spatula on my build plate and a mallet and hammer things off. And so you design around this. You put little bevels on corners so that you can get that spatula underneath. And it starts to inform the way that you actually design things as well. So these days, that's not an issue, but I still have all those same design features because I like them. They look nice. I have to step forward and read this slide. Right, so to some extent, this becomes a challenge, right? It's not just problems. It's like, yes, I can defeat this. I can win against these problems. And thank you, Courtney, for the call out there. But it still feels like a case of us and them. It's us versus the printers, us versus reality. and which is exciting, but it feels a bit masochistic at times as well. But that changes over time. Oh, hinges, yes. So hinges were a big thing for me. I'd been making boxes. I liked making boxes where tops slid onto bases and everything fit nice and neatly, because printers are really nice and precise. Even in the olden days, they were amazingly precise things. But I wanted to be able to do things like, I wanted to have a lid that hinged, and I wanted it to be come out of the printer ready to go. And I still remember, and you'll see in the next slide, the very first time I achieved that. And it was one of these things that you look back and think, how could I have made this so complicated? But it takes time to get to simplicity. But this was the very first time that I managed to have a print-in-place hinge, and I was just amazed. This is what it looked like. So it printed on an edge. There's a hinge line going up through one edge there. And it worked. And I was amazed. And you could pull this thing off, and the hinge just worked. And the printers are so amazing. But this really reflected the paradigms of real life, construction. It's the kind of hinge that you would expect to see if you had bought something pre-made. So, there's a post up through the middle of it. And granted, this is printed on an angle, so it probably needs that anyway. But it very much just reflected, if you were making this thing out of plastic and metal or wood or whatever, that's how you would do it. You would have something to bear the weight of the thing. But, there needs to be better ways. And so this was the second thing I did. And this was, transformative for me. It was like, now I can't have a post through the middle because it'll sag and it'll stick and so on. And so I didn't actually check, but I'm pretty sure that just went to good old cones. So cones that stick into conical dimples and just bear the things that way. So because all we really need is something that, constrains the movement. And that was exciting stuff, because that meant suddenly I could do other things. Like I could have clamshell cases, and, the only thing that changes from having things that go straight down to things that close over like that is that now you need clearances because things are swinging and so on. But that's all right. That's easy enough. But it, being able to have two things that print together was suddenly, a different way of approaching printing in general. And things like, those Raspberry Pi cases and so on. Now they could just be, oh, I'm getting a hurry up. Now they could be, I'll just talk faster. They could be print-in-place things, and it's more elaborate, more exciting, and I liked it. And those things change over time as well. So those previous ones, they were all symmetrical, but it's like, oh, I know. We can just decouple those hinges and make things arbitrarily sized and have lids that look like lids and so on, which was great. And then things like vase mode, as I have to say in my Australian accent, or vase mode, where it's a completely different set of limitations and constraints, where it's like, oh, well, we need to worry about, not just overhangs, but things in the other direction as well. And things like, making sure we don't have pockets in the middle because we can't have islands and things in that kind of printing. And it really is just a way of thinking about these things. Yeah, so these things become just the way you think about prints after a while. So, I would sit there and think, okay, I want to make this. How can I make this using this kind of approach? So this would be an example of something that I thought, I want to make this, and then it's like, how can I solve that thinking about things in this particular way? And likewise, it's like, I want to make this clamp, and I'm going to work out how to make that work with the hinges and the approaches that I have. But these are all things that, I've got an idea in mind. I wanted to make, icing that would fit into a donut and would have wobbly lines but still print without supports and so on. It's still just using all of these techniques, but to get to a particular end. And here's another one as well. Let's skip through this because we're running out of time. Different ways to have enclosures. But ultimately, is that my hurry up? But ultimately, no matter how complicated these things might be, they're still aiming to solve something. Let's skip forward to exploration. This is the good bit. So after a while, these limitations don't just become hurdles, they become sources of inspiration in themselves. Like, what if we make some gears and we actually sweep these things down and make them so they can be vertical? And they become sort of a place of finding things that we can build without necessarily having an idea in advance. So you're like, what if we just turn a vase mode thing on the side? Oh, now we can have overhangs, and it turns into an idea. So the thing that I really enjoy about 3D printing as the time ticks down is this ability to just start with the constraints and start with the limitations and just work forward from there. Like, what could this turn into? Which is the thing that, that's what I wake up in the morning thinking about, or when I'm having a shower. It's just like, oh, maybe I could try this. And that's what so much of this turns into. And so things like this, like, oh, I wonder if this would work. So all of these are just like, oh, let's start with the constraints and work from there. Now, the only thing, I'm going to skip over this because I've got 1 minute left. Layer shifts, oh no. Oh, look, you could 3D print that. After a while, you start to see the world in 3D printing terms. But yeah, after a while, it becomes about like, how can I just express what I'm trying to do in this sort of language of 3D printing and so on. But one thing that is kind of poignant is that a lot of these limitations won't be here forever. So, technology changes and so on. And, but the thing is that whatever comes to replace this stuff will have its own limitations. And I've wrote a comment about belt printings down there, I think, where it's like, wow, now we can have overhangs, but we can't have them in this direction and so on. So anyway, thank you so much for indulging me. I think I got in within the time limit. Thank you. Have sound. There we go. Yes, come see me down with Courtney from Filament Stories at the far corner, just down at the entrance near 3D Gloop with the cool purple stuff. Thank you. Just let me know when Oh, okay. Just ready to get started.
Oh, hello. So I'm Mike with AutoDrop 3D and Maker.cloud. I'm going to be doing a little bit of a demo today about the JSketcher browser-based parametric 3D modeler that we've been building. And it's available up on GitHub. You can self-host it if you want. But it also is integrated straight into the Maker.cloud. So we're not evil. So I'm just going to go in here and I am going to create a new part, and I'm going to just call this demo for the show. And I'm going to set the modeling method to JSketcher. Oh, is it not? Is it paused? Oh, you know what? Hold on, let me just clone the screen. There we are. Okay, yeah, so this is all fun. I'm on a Chromebook here, by the way. So this is 100% browser-based. So I set my modeling method to JSketcher and I saved it. And now I'm going to go over into the editor and wait for it to load. And I'm on a cell phone hotspot. Everything's happening locally in the browser except for storing the model itself. So we could go in, we could start doing something like sketching. So I can go and create a plane. It's got your feature history down here. It's got all these different kinds of standard kind of commands. And then this is the two-dimensional sketcher. So we can go and just go and create some geometry. And then if I want to get fancy with it, right, I could go and pick a couple of points and I can establish like constraints on them similar to Fusion or SolidWorks or anything like that. And maybe I want to go and set some dimensions on here. So I can go and set some stuff and set these things up. We'll just set that to like 200. Why not? And of course, you know, you have things like construction geometry, which is stuff that you use for kind of positioning other things, but you don't really want it to be part of like whatever you're extruding or building. So if you select it, you can turn things on or off. Okay. So yeah, we have the ability to create like construction geometry, which is geometry that's ignored for the purpose of actually making a model, but you use it for kind of controlling things. So that's what we did with this line here. And we could do other stuff too, like we could say these two lines are equal in length, and it goes and it makes it so that they adjust all the same. And this is all just that standard kind of parametric 3D modeling that you're probably used to in other CAD packages. So now that I've got a sketch created, let's just say I want to go and turn that into an extrusion. So we can just select the sketch and go to the extrusion command. I can enter in a number. And all of the dialogues, they all use the same stacked format there. So if you know how to use it in one dialogue, you probably know how to use it in the others. So we have like a standard thing for picking the direction. We have standard fields, and then we also have the Boolean types in most of the features. So now we have a little object there, and you can continue doing things to this. So maybe I want to sketch something on the front of the house here, and toss something on here. Again, I'm just going to use some simple constraints. I'm going to attach it on there, and maybe do a little dimension there. I don't know why it didn't show up. We're all, you know, working on the code, so a little something there, but it does remember what constraints are on things. So if I kind of like click on something, I could see what constraints are already applied to that particular thing. Like for example, if I pick that, it has that coincident constraint. And I can just get rid of it if I don't want it. And this really allows you to kind of like get in there and really fine tune the control of that model. And now I could do something like maybe I want to cut that out, and I'm going to indent it, let's just say 5, and we'll subtract that out. Now, You can also do things like standard kind of edge operations. So if you use OpenSCAD, you know how hard it is to do fillets on things. This is a real parametric modeler, and it uses BREP geometry. So BREP actually keeps track of the edges and the boundaries of the shape in their mathematical perfection. And then it goes and it turns it into the triangles. It's not just triangles all the time like some of those other systems. And I'm just going to go and put a fillet on there, and it put all fillets on the edges of those things. And of course, just like any other modeling system, I can go back in time and change something and set it up so that it adjusts the entire model. So I just made my house bigger. I'm going to make it extrude much longer, and everything else is going to update along with it because of all those relationships that we set up. And this is just like any other kind of parametric modeler, except we're running all straight here in the browser, and you can actually host it yourself if you want to. Now, that was pretty fun. We just went and made that model. But let's just say you had your cell phone, okay? And you wanted to go and make a quick tweak to that model. So I'm going to go and show my phone over here. Yeah, let's turn it sideways. Now, what we have is an emulation of a touchpad that overlays over the CAD software. So we have this crosshairs, which is the mouse pointer, the virtual mouse pointer, and I can manipulate it kind of like a touchpad. And let me get out of this part and load up the one that we just made. Oh, this is so much fun. You know, mobile modeling, you know, isn't exactly the best thing in the world, and there's really no good ways of doing it. But this is probably the least sucky way of doing this these days. So we will make this full screen. So there is that same model I built on my laptop right here in the browser. And if I want to go in and edit this, so let's just say I want to go and adjust that door size. Let me go and edit this, and it should, oh, come on. There we are, okay. So I can go and adjust that door position and drag it around, and I can add constraints just like I would in the regular modeler. And this is all straight from my cell phone. So you might not want to go and actually design things on here, but if you're someplace and you want to go and make a quick edit to a model, this is actually pretty handy. And I'm just going to go and finish out this sketch and finish that up and allow it to complete the history there. So now my model is updated, and it updated the whole thing. And now if I just go and I tell it to save it, it's going to be back over here, and I can reload this and have my, my model changes all done for me. So I just want to get like a raise of hands. What kind of CAD software are you guys using? Are you using Fusion 360? Okay. SolidWorks? Okay. Solid Edge? OpenSCAD? Okay. CATIA? NX? Okay. Well, it's very interesting. So how about FreeCAD? There are some difficulties in using FreeCAD. We actually have the ability to import FreeCAD models, native FreeCAD models directly into the system along with step files. And you can also export in the BREP format, which is a native format for FreeCAD. So there is some interoperability there. Oh, these demos, live demos are so much fun. So if anybody's got any questions, yeah, go ahead. What? Yeah, what was your question? We don't currently have like space puck support, but the source code is on GitHub. So if somebody has a little space puck demo which is compatible with 3JS, it would probably be pretty easy to integrate. Yeah, it's a Chromebook. I'm not going to touch it. It is pushed it as far as it will go. I'm not going to touch it anymore. It's just going to stay there. I'm not going to touch the keyboard. I'll only use the mouse. Okay, anybody else got any questions? We don't have the ability to import SVG, but we can import DXF into the 2D sketcher. And you can also export SVG and DXF from the 2D sketcher. And I can actually show you that. If I just create a plane and sketch on here, there's a little button here which pops out into an actual separate 2D sketcher. And the 2D sketching environment, you can import from other formats, including SVG and DXF. I don't have any handy for me right now. But yeah, the 2D sketching environment, you can also export, and that's perfect for like laser cutting if you want to use it for that. Now, just a little bit about Maker.cloud. We started out as AutoDrop 3D, and we had the automatic injecting printers and kind of a cloud-based workflow for managing them. So you could go and monetize your printers or make them available to a group of people. And we've kind of evolved that, and we've been working more on the design side of the software. But we do have that cloud printing capability, which allows you to take your 3D models, or allow your customers to go create an account, send their prints directly to your printer, charges their card, you set your prices, and you get a check once a month if you have orders. So you can basically put your print farm on autopilot if you want, and it handles all the slicing and actually starting the jobs for you. 10 minutes? Okay. So let's go back over to the 3D CAD, and I'm going to just kind of pull up a slightly more sophisticated model. We have a whole bunch of different features in here. I'm going to go in, I'm actually going to delete out this fillet, because everybody knows fillets are always the things that you put on last in general. That's a good rule of thumb. But I'm going to go and I'm going to mess with this model a little bit and show off some of the other capabilities. So I'm going to make this indentation for the door much more pronounced. And then let's go and try something here. So we have the shell command. This will allow you to take an object and to pick a couple of faces on it and say, I want to hollow this thing out. And that's very useful for like making like boxes or little drawers and stuff like that. So I'm going to go and run that. And I love it when demos work. So it went and hollowed out that for us. You also have some other different options here. We have the linear patterns and the radial patterns. So if I wanted to go and make a radial pattern, I can select a solid. I can pick the type of angle I want. So this is like step and angle, so it's going to be 50 degrees between each element of the pattern. If I hit span angle, oh, I know I said it wasn't going to touch the keyboard, but let's do 360. And now it wants me to pick a vector. So what I'm going to do is I'm going to pick an existing edge in my model, or I can pick like a line I drew in a sketch. And it gives you this kind of like this little picker mode. So if there's multiple things that are underneath your cursor, if you hover for a little bit, it lets you get a list of them and you can select easily which one you want. Come on. Let's pick that, and it unselected my body, so I'm going to select my body again and hit OK. And there we are. It went and made us a radial pattern of weird little house things. And of course, the linear pattern also works the same way. And if I really wanted to, let me go back in and edit that pattern. So nothing's set in stone here. You can always go back in time and edit something from earlier. Oh, why is this so small? So let's say I want to go and make that 4 of them there. So that's going to go and roll 4 of those little things there. And we can do this for all sorts of different shapes. We also have the capability of doing lofting. So let me just start up a brand new part here. Going to set this to JSketcher and save it. And then we'll go over here to the editor and edit with it. So lofting allows you to take 2 separate profiles and sweep in between them. So what I'm going to do is I'm going to go and toss a couple of different planes in here, and I'm going to go and position some more planes. Just going to toss some datums in here, and you can kind of pull on the axes of the datums whenever you create them. And we can create some kind of fancy shape here. So if we sketch something on this plane, let's do something like this. So it's kind of weird. And now we'll sketch something on this plane, which is going to be completely different. So I'm going to actually make a proper rectangle here. And we'll go and do something over here. And I'm just going to go and draw a circle on this one. So we're going to go and create basically a loft through all these profiles. So we'll go and we'll pick the profiles that we want. And we're going to tell it that we want it to be a smooth loft. We can always do that a little bit differently. And there we are. We've gone and created some very fancy geometry there. So you could picture using this maybe for like a radio-controlled plane wing, or doing some kind of complex shape that you wanted to make. And of course, if I want to go back in here, I can always edit things. So if I go back in here and edit this feature, let's see here. If I want to go and make this sharp, right, because this is going to go and basically draw straight lines in between everything as opposed to having it do it smoothly. So there's a lot of different kind of capabilities you could do there. And of course we have the fillet command. Now that fillet command, when I used that earlier, we only made a fillet, but fillets and chamfers are basically the same kind of a feature operation. So why wouldn't we just go and combine that into one command and allow you to change it from fillet to chamfer? So let's see. It might not work on here, but you know, we'll see. We're doing weird loft geometry, so things could get a little squirrely. And of course, it's not bug-free yet. but it's getting there. And the fact that it's running all on a Chromebook or on your cell phone makes it quite handy. How are we doing on time? Are we? How are we doing on time? So if you want to find out more about this and actually take it for a spin and play with it a little bit, I'll be over at the Maker.cloud booth. And that's all the way down here on the left. Good. Oh, I still got 5 minutes. Well. Well, if anybody else has got any kind of like Q&A, you know, more than happy to go and talk about different things that we have here. We have something else which you might find interesting for the OpenSCAD people. So you have the option to use OpenSCAD files in Maker.cloud. And this actually uses a browser-based version of OpenSCAD. So you can actually, and it has a working customizer. I don't know whether I have any demo models available right this second for that, but it is awfully handy, and you can use this just yourself at OpenSCAD.cloud. You don't actually necessarily need to have an account. You can just paste your code in there and run it. And it is something that runs client-side on Chromebooks, so you don't have to install it or nothing. So because everything runs client-side in the browser except for the storage, we don't have much infrastructure cost there. It's just CDN hosting. The storage is the only thing that costs something, and if you're making oodles and oodles and oodles of models, maybe we would have to talk, but it's pretty much it's pretty much open and free. And there's a plan at some point to make it so that you can make the models available to other people and then have them print out on the network of printers. Any other questions? Okay, well, thanks for listening and taking a look at that.
Hey everyone. Oh shit, my bad. My bad. Great to see you guys here. So we are 3D Hub Canada from Toronto, and I have my partner Eric here, and our founder is at the booth right now, so explaining the products that we have. So make sure you come check us out at the booth. We also have some free giveaway, some freebies, so make sure you guys come grab yours before they run out. So our mission here is straightforward. We are here to offer the highest and best 3D printer parts available at affordable prices, especially for consumers like you guys or even experienced professionals. So make sure you visit our website, and we have a large catalog for you guys to choose from. However, our focus today will be in the realm of 3D scanning, and we are honored to partner up with RepRap today because they have a huge potential to disrupt this very field and then at the same time benefit everyone that can make use of it. So, okay. So what is 3D scanning? So 3D scanning pretty much creates a bridge between a physical and the digital realms, at the same time opening up a world of possibilities for both professionals and hobbyists, for industries ranging from manufacturing and engineering to even healthcare, art, and beyond. It also enables us to replicate and analyze and even interact with real-world objects. And this really is invaluable to innovation and creativity at the same time. So by definition, 3D scanning is the process of capturing the physical shape and dimensions of an object in the three-dimensional space. This technology has seen many advancements and has evolved a lot over the years, ranging from the 1960s when the first laser-based measurement systems and even photogrammetry were first developed, to the 1990s when structured light scanning was developed, and to now we have greater accessibility and also wider market adoption of 3D scanning in general as a technology for 3D hobbyists. So 3D scanning has different technologies such as laser technologies, structured light scanning, and also photogrammetry. Laser technologies create point clouds, so essentially it's measured X, Y, Z points in the 3D space that can capture and pretty much an object and then create a digital form of it. So types of laser scanners include laser pulse, which measures the travel time that it takes the light to get to the object and then bounce back off to the sensor. And then we also have laser triangulation. So that measures not the time it travels, but the angle at which it bounces off the object and then comes back to the sensor. So those are different types of technologies that laser technologies make use of. Also, we have structured light scanning. So this pretty much projects different light patterns onto an object, and then the sensor will capture the distortion of the light onto the object in order to capture the 3D form of it in a digital format. And then we have photogrammetry. So this is a very, has been here for a long time already. It uses multiple photographs from different angles to create the digital form of it. So take a car as an example. You stand here, take a picture, and then you rotate 5 degrees every time, take another picture, and then there's a software that would help create that digital format of that object for you. So I hope these definitions do not bore you guys too much. So moving on, we'll be going through some of the applications, use cases, and pros and cons of 3D scanning.
3D scanning is used in an educational setting to enhance learning experiences and promote hands-on exploration. In my school, at least, we use 3D scanning to print real-life replicas for my computer science course. Scanning is also applied to preserve, document historical artifacts and artworks, and plays a crucial role in the medical field, particularly in applications like dental impressions and prosthetics. It's also used for reverse engineering, allowing the recreation of physical objects in digital form. It's also utilized in the entertainment and gaming industry to create realistic virtual environments and characters. Designers use 3D scanning to develop intricate and precise models for various products and projects. 3D scanning is employed for human body scans, which have applications in healthcare, fashion, and more. So while the applications of 3D scanning are undoubtedly exciting and promising, it's essential to recognize that this technology also comes with its fair share of challenges. Let's explore some of the variables. High accuracy is crucial in 3D scanning, especially for vital fields like medicine and aerospace. Achieving this precision can be tough due to calibration, environment, and scanner quality factors. Maintaining error-free scans is a consistent challenge. Speed is a critical consideration, especially when dealing with large or time-sensitive projects. Some 3D scanners can be slow, which may not be suitable for industries that require rapid data acquisition. Balancing accuracy with speed remains an ongoing challenge. Resolution and detail are crucial for capturing fine features and intricate textures accurately. However, not all 3D scanners offer the same level of resolution, and this can be a limiting factor when scanning objects with intricate designs or small-scale features. Reflective surfaces, such as metals or glass, pose challenges as they can cause glare or reflection in scans. Leading to inaccuracies, finding ways to effectively scan high reflective materials without distortions is a continual challenge. Objects with complex shapes or intricate geometries can be difficult to scan comprehensively. Some scanners may struggle with irregular surfaces or deep crevices, making it challenging to obtain complete and accurate scans. The cost of high-quality 3D scanning equipment can be prohibitive, particularly for smaller businesses or individuals. Finding cost-effective solutions that maintains accuracy and performance remains a priority in the industry. 3D scanning often requires specialized training and expertise to operate effectively. Ensuring that scanners are user-friendly and intuitive is essential to broaden their accessibility. Integrating 3D scanning seamlessly with other technologies such as CAD software or 3D printing can be challenging. Compatibility issues can arise when different hardware and software systems are used together. Addressing these challenges is vital to unlocking the full potential of 3D scanning technology and expanding its applications across various industries. As technology continues to advance, ongoing research and development efforts are essential to overcome these obstacles and make 3D scanning more accessible, accurate, and efficient for all users. The following examples are taken from an online forum. These guys are truly skillful in the designs, and we truly thank them for their work. So the first one, a Lego figure. When scanning small objects like a Lego piece with intricate angular details, maintaining high accuracy and precision is essential. The scanner needs to capture each edge and corner with precision to ensure that the digital model faithfully represents the physical object. Achieving lower resolution scan might miss fine features, compromising the quality of the digital model. Scanning small objects efficiently can be challenging, as it often requires meticulous positioning and multiple scans to ensure completeness. Balancing accuracy with speed is crucial to make the process efficient. Sea snail. The rough white surface of a sea snail can lead to challenges with reflectivity. To obtain an accurate scan, the scanner must deal with potential glare or reflection, which may distort the captured data. Ensuring that the scanner captures the fine texture and irregularities of these sea snail surfaces requires a high level of resolution. Inadequate resolution can result in a loss of crucial details. The shape of a sea snail can be irregular and complex with curves and twists. Capturing this complex geometry accurately without missing any features can be a significant challenge. The last one, a shoe. Scanning a shoe with intricate patterns on the sole and the shape that needs to accurately mold to a person's feet is a multifaceted challenge. Achieving high detail and precision while capturing the three-dimensional shape accurately is critical. Shoes often have complex curves, arches, and contours that make them comfortable and ergonomic. The scanner must capture these intricate shapes to ensure a proper fit. For practical use in the footwear industry, 3D scanners need to be user-friendly for designers and manufacturers. Easy operation and software that can process the scan data efficiently are essential. And the scanned images here you saw on the slide are the actual cases of RevelPoint's 3D scanners. So we got a video for you guys. It's about 120 seconds that we're gonna play. Technical difficulties. Just play it. It won't play. So this 3D scanner in particular has the ability to scan an entire human body in just 120 seconds. After this, we got some case studies for you guys. Give me a second. So the first case study is obviously in healthcare. Corey Robinson, a mechatronics designer, he was injured and fractured his calf doing an outdoor activity. His orthopedist used a RevoPoint 3D scanner to scan the injured part to obtain 3D data, then designed a grid-shaped plaster split for him. So the second case study is a minifigure design. A famous Japanese miniature landscape artist used a RevoPoint Pop 2 3D scanner to produce a large number of 3D miniature models of the Tokyo subway station and its characters. The models were vivid and realistic, and the artist demonstrated an artistic perspective of the meta-universe. He was able to perfectly combine technology and art using a scanner as a medium for artistic creation.
Okay, so here we have in our professor that was able to scan some antique from the 17th century, and that provided very accurate and intricate details of the complete vase, and he was able to pretty much replicate it in a digital format here. Here we have a mechanical engineer that was able to scan with a RevoPoint Mini Pop 2 3D scanner to scan in aluminum engine cylinder, and that allowed him to obtain a very high precision engine model, and also allow him to retrieve accurate detail of how this engine cylinder is, including dimensions and everything. So RevoPoint has many products, and up here you can see 4 different products that serve different purposes with different resolutions. All of them are able to provide you with ready-to-print 3D formats, 3D object in different format, and you can check out their website for the different technical specs that they have. So now, how does RevoPoint compare to other products in the market? As you can see on the left side, your left side, this is a professional scanner used by dentists to pretty much scan the teeth of the patient. And then on the right, you have what RevoPoint is able to achieve. And you can see that the level of details that the scanner can achieve with the RevoPoint is very similar. And all that is doing so with a scanner that's very time efficient, also cost efficient. So you don't necessarily need to go with very high-end scanners in order to achieve good results. So that's all for the presentation. Make sure you guys come check out the booth. We also have ambassadors from RevoPoint that can explain more of the details of the scanners that you guys may have if you guys have any questions. Thank you.
Testing. They're having a little problem getting the video to go to the stream, so we're just going to take 1 minute and see if they can fix that and get that to work. So thank you for your patience. All right, well, thank you very much. Sorry about the little technical delay there, but we'll try to move through these relatively quickly. So my name's Joan Horvath. I'm half of a two-person company named Non-Scriptum. Rich is my partner down there, as always, doing all kinds of good technical stuff. And so we're going to talk about our math projects. Next slide. So a little bit about us. We've written a whole bunch of books together. We have an exhibit up on the, kind of behind the B on the second level over there. So we're going to just run through this very quickly, but we're happy to talk to you at more length about all of this. So Rich, some of you know, is Who's a Whatsits. He's an old RepRapper. He's the old guy in our partnership. And so he's done a lot of things in this. We started this company after we had a 3D printer company for a while, and we've started doing training. And after we started doing training, we discovered that a lot of teachers didn't know what to do with 3D printers, so we started building curriculum. And that's what we'll talk about today. Go ahead. So our philosophy is to teach math with physical models first and algebra second. And a 3D printer is a really good implement for doing that, obviously. And go ahead. And so what we try to do is embody universal design. A lot of our models were started as models for blind children, actually. And so there's a long backstory there. If any of you are special ed, some of you are nodding. And so universal design means that you make it better for some group of people that are completely shut out, and then often it makes it better for everyone else. So we try to embody universal design. Go ahead. So we teach with, all of our models are written in OpenSCAD, which is an open source CAD program. It's free. It also is, interestingly, the only accessible CAD program because it's text-based, so people who are blind can use it with a screen reader. So we work with them a lot also. Go ahead. And so the way all our models work is that OpenSCAD, we have OpenSCAD models in our repo with our books, and the models are designed so you only have to change some parameters. Go ahead. This is what OpenSCAD looks like if you haven't seen it. So it's a code-based CAD program, and we've designed it so that you only have to change a few numbers for most of our models, so it's not scary, and you should be able to use it. Go ahead. So our first books were of science projects, and I'll just show you a few models from that up here on the screen. So for instance, we have a model of plant growth, and so there's an example here of a real plant, but plants have certain characteristics. They lay out their biomass in a way that's very efficient. And so we've modeled that, and if you change a few numbers, you can make yourself plausible-looking alien plants. It's really fun. And you can teach kids about this really easily by saying, here's the rules that plants follow, more or less, and play with that and see what you get. Go ahead. We also have what we call our non-scriptum Air Force. So we have models of accurate World War II airfoils. You put them on a postal scale, you blow a fan on them, and because the wings generate lift, they get lighter, and so you can measure the lift. The model lets you change the angle of attack, it's called. And so you can do some, from little kid, isn't this cool, to pretty sophisticated aerodynamics, and talk about the errors and what the problems are and so on. Go ahead. And so we did those books, and people said, you know, it would be great if you could do an entire subject somehow. And so that's what we've gone ahead and done with our partners at Make, the people who do Maker Faire. And so we're going to talk quickly about some of our math models. Go ahead. And so Rich is going to switch over here and show us some math models if our high-tech works here. So first he's going to show us one of our models from our Make Geometry book. And so that is a model that it's also in our trig book, as it happens, to teach you about sine and cosine. So the hypotenuse of that triangle is scaled so that it is 1 in some units. You can slide it up and down to get different angles, and you can read the sine and cosine off the side, and it's just got little tick marks in it because it was originally designed for blind students who read with a fingernail. But you know, you can read easily too, and I've had pilots ask for it for calculating crosswinds, which I personally find kind of scary, but because it's not meant for that. But anyway, it's kind of a fun one. The next one is what's called a net. And some of you may have seen things that look like this that are cut out of paper to make into shapes. And they're good as far as they go, but Rich's big insight, Rich designed all the models, I should say. Rich's big insight was if you filled the volume, you could reason about it. And also it makes it accessible for our visually impaired, or a lot of interest for the deaf community too, I'm not sure why. So you can make those models and you can hand it to a kid and say, okay, what's the volume of a pyramid? And they can figure that out, you know, deduce it from a cube and all that kind of stuff. So we have a whole bunch of models, all the platonic solids. Very simple to do in OpenSCAD. There's another one that he has there as well. Okay, and so calculus in 1 minute. So we will teach you calculus in 1 minute. I think you have to move it up a little bit. So if we start out with just these yellow ones, which will take off those. So what we have here is the curve x squared. It's 0, 1, 4, 9, and 16 Legos. Those are just regular Legos. We haven't printed them or anything cute like that to make it easy. Our calculus book has all the first problems in form of Legos and pictures of Legos and answers in pictures of Legos. And so if we look at the difference between the two tallest ones, that's 7. And Rich is going to put it in between to show that it's the difference. And if we look at the difference between the next two, it's 5. And we'll put that down to show that's the difference. And 3, and 1. And we get a little curve of the differences in front. And that happens to be the shape 2x. And that's what a calculus person would call the derivative of x squared. So you get this curve of the differences. And then you can say, well, what would happen if I added up everything underneath that? That's what's called taking an integral. So Rich can add up the first 2 points. They stick sometimes. First 2 points and show the curves are equal. Then you can keep going, show the curves are equal. You can keep going and show the curves are equal. So this is a really easy way to give the very, very basics of calculus and do that. And you might say, well, what happens when it's not even numbers? So we solved that with a 3D print. So we have 3D prints that are scaled to the Legos, so you can make this distinction without students having to make an intellectual leap, so that we have x squared and we have 2x, and we can turn those back and forth and say you can integrate one way and differentiate the other way. For if you don't know calculus, come up to our booth, we'll explain this to you more slowly. And then it's really fun with sine and cosine. Here's a print of a sine wave. When you turn it 90 degrees, you get cosine, which is derivative. Turn it again, you get second derivative, third derivative, and you go the other way to integrate. So it also happens to be an E and M wave because there is that same relationship. So it's a fun way to learn about these and play with them. And you have not seen any algebra, have you? And if you look at Isaac Newton's original book, Principia, there is no algebra in that book. It's all drawings. And so we've gone back to Principia and said, what would Newton have done with a 3D printer, and try to play around with that. So do we have any models left? No. All right, so again, this is just a little bit of a taste, and I know we were supposed to keep it down to 15 minutes here. We have a little time for questions. If anybody has a question, you have to really shout it out. And if not, we'll just get you out of here on time and come visit us. So here's make trigonometry and make calculus. Make geometry is up in our booth, and I have flyers and stuff here. So thank you very much.
Testing. Can you guys hear me? There we go. Okay. Okay. I guess I'll go ahead and get started. It's 4 o'clock, so thanks everybody for attending my talk. My name is Mason McNair. I'm a PhD. I'm currently at Clemson University in South Carolina, where my degree is in plant biology, but I do 3D printing for pretty much all realms of biological sciences. And so today I'm going to talk to you about some of our ongoing projects and collaborations, and just kind of show off some of the designs we've done, and put out a call for future collaborations, because we need sponsorships and funding to do science, because that's how it works. So thanks for attending my talk, 3D Printing for Science. Okay, so who am I? I started my bachelor's in horticulture at NC State University, and then I went to UGA in Georgia to get a PhD in plant biology, and now I'm a postdoc. Somebody wants something good. And so now I'm a postdoctoral fellow at Clemson University, and I'm currently on the job market for a tenure-track professorship somewhere. So we shall see where I end up. But in the meantime, I've been working on 3D printers, or with 3D printers, since about early 2020, when my first Mark III showed up as a birthday present. And I'm completely self-taught when it comes to 3D printing. I've never taken an actual formal course, but I would say proficient in things like Fusion 360 at this point. Current printers in our lab, we've got a Prusa XL 5 tool head, day one pre-order that we're still waiting on, Joseph. Sorry, I couldn't help but throw some shade. My original Mark III's and 2 Prusa Minis, one of which Prusa was nice enough to donate to us. We've got 2 resin printers, Photon Mono X and the Photon Ultra. And my boss ordered a Bamboo Lab X1C and AMS because he was tired of me tinkering all the time and just wanted it to work, which I'm totally fine with it. It's honestly a great printer, but we have our differences in opinion about the whole open source, closed source thing. And I know it's a point of contention here, so if you want my honest opinions, I will give it after my talk. And also we have a Recreator 3D unit. Even more giveaways. A Recreator 3D unit that Josh Taylor, if you haven't met him, he's in the far corner booth. He's got some of our prints on display, and he is fantastic. He's been extremely supportive of our research. He gave us an amalgamated unit that's pictured there on the slide. But we're expecting a new baby at the end of Earth, and that is the Baby Belt Pro. It is joining the fray in our lab, where we will very much put it through its paces. If you have not seen the Baby Belt Pro, it's like the only belt printers here. That's at PrintCep's booth, back next to, also in the back corner by Recreator 3D. So he built that green one that's back there specifically for us to test out, and I'm very excited about it. So the goals of our research, well, I say our, it's really just me and my PI, Dr. Reif, is to incorporate 3D printing in traditional biological research, but especially plants, make our designs affordable, repeatable, and open source, and enable as many people as possible to get involved in science and 3D printing. So how we're doing that is through networking at events like EARF, the Botany Conference, which was in Boise, Idaho this year, and I'm hoping to go to Madrid, Spain for the International Botanical Congress next year, where I will put on a workshop. We've got active collaborations with Prusa Research, Filamentum, Hex Hives, which I'll talk about a little bit later, and we've got sponsorships through groups like Gizmodorks, LDO Motors, Polymaker, Slice Engineering, and Wham Bam. And that's just a small sample. And then we do a lot of outreach through the workshop that I host at different conferences, where I teach people about how to use 3D printing, from the basics of if you've never used a 3D printer before, all the way up through optimizing your prints. Even with like the amazing automation we have now, getting your prints really dialed in, especially for functional parts, is really key in our field. So, our current projects. I'm gonna talk about seed stuff. As a plant biologist, we work with seeds a lot. We've got volatile compound assays that I'll... Okay, one moment. Okay, so we'll talk about volatile compound assays. I'm gonna talk about bees. So I do a lot of work with our local apiarists, or beekeepers in South Carolina. and we've got CDK's Rhizotron projects, and then a paper we've got coming out this month on the collection of bespoke laboratory equipment, which is called Cobble, and then I'll talk a little bit about our future projects that we're looking for sponsors and help with if you're interested. And that's a picture of our current lab setup with all of our different printers. And so it's not a huge maker space, and we're in the middle of nowhere, South Carolina, at a research station, so we don't have like the main campus traffic, but I like our little lab, and we print stuff constantly, so it's wonderful. Okay, so seed stuff. One of the biggest things in biology, in plant biology especially, is the threshold for what's novel is really, really low, because we need custom equipment all the time, and people are so used to like making out of like duct tape in a scrap wood that having a 3D printer can really just rapidly improve the quality of research. So the bar is honestly really, really low. So when someone like me came along and my PI has no experience with 3D printed tools or anything at all, he just came to me and goes, hey, can you make a tray that will quickly count and sort seeds of different sizes? And I said, okay, sure. So I designed this in Fusion 360. It's a fully parametric design that we're going to publish and release open source. We also have additional things that I'll talk about in a second, but it's customizable for your seed size and shape. And the handle's hollow, and I've got these in the back with some seeds if you want to see them in action. On average, though, we get less than a 5% margin of error on our counts. And they're also great for just, we can do top-down imaging as well. So if we want to do phenotyping and things like that, we can just place a camera setup and take top-down images. So in addition to that, we've got sieves that are fully parametric, so we've got rounded ones and square ones. The left one was the initial prototype just out of scrap PLA we had lying around. And it was meant primarily for green beans and lima beans, especially when you're shelling them. The one on the right is for mustard and mustard relatives. So we've worked closely with the USDA to develop these sieves because it greatly increases their efficacy of their research. Again, I said the bar is quite low. It doesn't seem that novel to create a sieve and a tray, but in biological sciences, you're doing this by hand or paying someone to custom CNC mill this. And so coming in as a 3D printer, we can come in and do this super cheaply and affordably. So it's a really cool technology to implement. And then the next thing we're working on is a sorter. So these are some designs. I pulled these off of printables all from the same guy that has done these bead dispensing mechanisms that are almost entirely printed. And basically what we're going to do is remix his designs and make them function with seeds so we can quickly dispense seeds into like germination trays, like well plates for like germination studies, things like that. And so my current goal is to make this a fully parametric design so that you can just plug and play whatever, measure your seed sizes and hit print. So that is my current project that I've got going on, or one of them. So volatile compound assays. Oh, that did not progress. There we go. Okay, so what you're seeing here on the left is a 96 well plate where we took a hole punch and took leaf punches from a bunch of different green bean varieties. A lot of you probably don't know, green beans contain a precursor compound for cyanide, like the gas that kills you. And it's to deter predators. Now, that's why you can eat the leaves when they're fresh and not mature, but once they're mature, that's when they start producing that compound in larger quantities. Those little strips of paper with the dots of blue, those are a paper that's been treated with a chemical that reacts to the off-gassing cyanide. And so if it turns blue, that means there's cyanide present. If it stays white, there's not. So what we found is that the different varieties it's really variety dependent of the green beans. So different varieties have different levels of the compound. And so we created this 3D printed jig that's pictured in the middle and on the right that holds those strips that are not safe to touch in place, so you don't have to touch it. You then put that 96 well plate onto that jig, and then there's clips that go on the side and hold the plate down, and you just let it sit for a set amount of time, and you pull it off, and then we take an image, like the one on the right, and can quantify using computers, programs, how blue it became. over that set period of time. So we can then quantify the amount of cyanide being off-gassed by the leaves. At least that was the idea. It didn't work quite as well as we were hoping. It ended up being more of a presence-absence thing because some lines have cyanide, some don't. But it was still a really cool, fun thing to design, and they're now using it in the sorghum genome project out in Colorado. So they're developing a really crazy detailed genome for sorghum. For those of you that are familiar, it's a grain crop that you can eat it. It's not particularly tasty, but it's sorghum. It's fun. It's a pretty plant, but it also has the same cyanide precursors. So now we're getting on to bees. So bees, this, again, I'm a plant biologist, but my office is literally next door to the state beekeeper for South Carolina. And he came to me and said, hey, I have some ideas. Can you help me? And I was like, definitely. That was, feedback. So he came to me and he's like, we already have plastic foundation that is being put into beehives, and the bees don't like it. And I said, okay, well, do you know what type of plastic it's made of? And he said, I don't. I just know the bees don't like it. And so I said, okay, I'm going to reach out to all these bee foundation manufacturers and ask them what they're using. Pretty much everybody is using polystyrene. For those of you that are familiar, polystyrene is packing peanuts, not the lickable cornstarch ones, the ones that don't break down ever. So that's really intense styrofoam. But in 3D printing, we have high impact polystyrene that we use as a soluble support material, or HIPs, you might have heard of. So what we're doing is we've created these choice chamber experiments where we're going to take essentially a vented mesh cage and just dump about 100 to 300 bees inside of it in the middle of winter when they're hungry and don't want to do anything and they're going to be super grumpy. So, and we're going to give them these little wells that are pictured from the top here that have sugar water in them. So we're going to feed them. But each of those little wells is printed in a single plastic. And so we're going to do pairwise comparisons where we have, for instance, high impact polystyrene versus PLA, high impact polystyrene versus PETG. And so we're trying all these different plastics, and thanks to, in the bottom left corner, you can see the sponsors for this research. They're supplying us with a lot of this filament. And so each of those little wells is only about 8 grams, but we have to do so many replicates to get any sort of statistical significance, which is very important for science, that we're going to go through about a whole roll just for this project for each filament. But again, we're going to stick the bees in those 2-gallon transparent containers. We are still deciding if we want to use like polypropylene containers or like a wire mesh, because we're trying to minimize factors that could influence the results. So it's about an hour to print each one of those, and I will tell you this, I spent the past 2 weeks printing every filament known to man. I hate polypropylene so much. It is the worst filament to print with. If you can avoid it, do it. No offense to any of the companies that make those filaments. I'm sure it's great. We have the equipment to print it. It does not like to be printed. With that in mind, we're gonna video the bees in the choice chambers and all these pairwise comparisons, and basically monitor how long it takes them to drink all the liquid, but also how many visits that each of the plastics get. And what we're hoping to get from that is a total result of how much they like or dislike different plastics. Next, we're going to 3D print foundations. So these are a stack of foundations all in different filaments. So foundation, when you put it into a hive, for those of you that don't know, is basically the frame that the bees are going to draw the honeycomb off of. Also, I didn't know anything about bees until about 3 months ago. So not a bee expert, not pretending to be a bee expert. I'm a plant guy that's into 3D printing, and so I will do my best, and if I say something wrong, I'm sorry. Feel free to correct me after the talk. So these are foundations that we printed out of all sorts of different plastics. I've got a few at the back at the recreator table if you want to see them in person. And we're going to do 2 prints for each type of filament. We're only going to print they take about 4 to 6 hours depending on the filament. And we're going to treat one with wax so that the bees have like a more familiar scent. That's also a common practice with even basic wax foundation. You do an additional wax treatment, and then you drop it in the hive and the bees draw out the honeycomb. But we're going to do one that's just pure plastic and one coated in wax. Like I said, it's about 4 to 6 hours in print time. There's 80 grams of filament per print. So we've got to do at least 2, and we've got to do 3 replicates for each 2 So that's 6 of these. So we run through a lot of filament very quickly. That's why Polymaker and Filamentum are sponsoring, is they are giving us most of the filament. And so we're going to drop these into our current hives in spring. And once we do that, we're going to leave them all summer, and we're going to quantify both the amount of honey produced, the amount of comb drawn out by weight, and we're also going to send the honey off for chemical analysis to see if anything's getting pulled out from the plastics, because you don't want microplastics in your honey, really, you know? And so this is a really easily implementable project, especially because we've got over 50 hives at the research station that I'm at already. So we just have to drop these in and go, and just wait for the bees and see what they do. And the last bit about bees is hex hives. So I've got a QR code up there that links to their Kickstarter. They are currently kickstarting this project. With the jury is out. They've gotten them working in Southern California. If you're a beekeeper or interested in beekeeping, they have, I think, decent data showing that they work in Southern California. I don't know, and that's why they're partnering with us, is to test them in other conditions. So they heard about our plastic testing for the foundations and the choice chambers, and they're like, hey, we don't really know what the optimal plastic is for this. Can you help us? And I was like, definitely. So they sent us the design files. So these are the sample GIFs, I don't know how to say it, nobody does, for how and what the hex hive design is. These are the first versions, so these are their prototypes, and I've got a prototype in the back if you want to see it in person. But what we want to know is, there's been a lot of discourse online because it's the internet, right? People like, oh, this won't work, and I'm like, well, we don't know. Yes, it's a really weird design compared to the traditional rectangular Langstroth hives. However, I think it has promise. I really do. Like, again, not a beekeeper, but I'm a scientist, and I don't see, why not give it a shot. So that's what we're doing. And we're hoping to have publications out, hopefully end of next year, with initial data on these and whether they're fully functional or not. But some of the things we're wondering and we're going to try to implement is answer of, do they work as swarm bait boxes? So beekeepers a lot of times will see bees swarming out in the spring, and they'll try to go catch the queen. And so you put out a bait box with a little bit of sugar water. It's usually a really small box, and you can enclose it. So once the swarm goes in there, you close it up, you've got a new colony that you can set up. Well, hex hives are not particularly large. However, they can be scaled up depending on what size printer you have. So that is the nice thing about their design, is it's fully modular. So we want to know if the bees have a plastic preference, hence the choice chambers and foundation experiments. And we want to know if they're going to hold up over the hot, humid summers of South Carolina coastal plains. And then can colonies overwinter in them, because we do get more freezing temperatures than Southern California. So those are our initial tests that we're going to run next year. And we're just really, honestly, I'm really excited. The two people that are running the Kickstarter is just a dad and son team, Luke and Kevin. Honestly, they have their hearts 100% in the right place. The price tag is a little high, but for the Kickstarter, you get lifetime updates for all their designs moving forward, which is really cool. So it seems like a lot, but you're getting those lifetime updates with the product. I'm not getting paid in any capacity from them, so I'm only telling you this because I genuinely believe in the product. I think it's neat. And especially for like researchers, it's a great low-cost method to get involved in research for bees, especially with colony collapse disorder and all the issues we're having with climate change. This could be a game changer in the research world, and so that's really why I got involved with it. Okay. So this is one of my favorite projects, CD case rhizotrons. There's a paper that came out in the Applications in Plant Sciences journal last year where someone was like, hey, we're going to use CD cases to grow plants. A rhizotron is just a way to grow plants so that you can see the roots without having to mess with them or disturb them. And so what's pictured in the top right is our imaging platform with an app that my PI, Dr. Reif, developed called Fieldbook. It's free in the Google Play Store. If you want to take agricultural data in the field without having to use a clipboard, that is the app. It's got like thousands and thousands of downloads. So farmers, agriculture people, all over the world are using it. It's a really cool platform. But we're using it in the lab to take pictures of, that's a little sorghum seedling growing in these CD cases. So what it's allowing us to do is we're phenotyping, so looking at the way the plant is presenting and how the roots are growing over about a month-long period. And there have been studies that have shown that the angle at which the roots are coming off of that primary root, like the one in the picture there, are linked to biomass accumulation traits. So we use sorghum for biofuels a lot, so like biodiesel, things like that. Honestly, jet fuel is largely biological based now, and ethanol. And so sorghum, when you screen for traits like that, it has been traditionally done in the field, and it takes a very long time. You have to grow the entire season, and then you have to excavate the roots without disturbing them. I don't know if you've ever tried to dig a plant up without disturbing the roots. It's pretty much next to impossible, unless it's a large tree and you have a crazy expensive tool called an air spade. That's a whole other talk, though. So this platform allows us to rapidly phenotype and image these plants in about a month. We can get all the data we need to screen these like 300 breeding lines, and it standardizes the imaging so we can quickly process the images and analyze the root structures. We can optimize, or we did optimize the growing angle, so you can see in the bottom I've got the cutouts of them growing upright, 15, 30, and 45 degrees. For sorghum, we know 45 degrees is optimal, and all those cases stand up. The snaps on the side are, for the CD cases, just snap fit in place. We did everything out of PLA because we're indoors, but we could adapt it for outdoors by using something like ASA or PETG, no problem. And you could literally print, so those are the low profile stands, so we want to save plastic that we're using, but we have full profile ones that cover the roots up. Normally I cover the case in tin foil because labs have a lot of tin foil laying around. But yeah, so this is a really cool project that I'm looking forward to hopefully getting published next year. But I'm literally still taking data. One of my lab mates is taking pictures of my plants while I'm gone. So thank you, Walker, if you see this talk. Okay. The last real big thing that I'm excited to share with you is a paper that's being published this month. This is Cobble, the collection of bespoke laboratory equipment. So the link there takes you to our printables post about it. This is a labor of love project that started in 2020. So right after I started 3D printing, I was doing my dissertation when I was doing a lot of DNA extractions, and basically our lab equipment kept breaking. And and our PI, being COVID, like everything was out of stock and out of order, and so I started 3D printing parts to replace it. And so with Cobble, this is basically all the random things that I have had to create in the lab since 2020 to complete my dissertation research. And so we've got organization racks. Yes, there are tons of these things out there already, and these are essentially, a lot of these are just my spin on it, but we wanted to create a cohesive set that could be used and be used in conjunction with each other. So this is really, the Cobble system was designed for bespoke or hyper-specific uses in the lab, but it's really adaptable to all sorts of cool things. So we've got organizers, which is A, we've got freezer tube racks is B, regular tube racks for working on the bench for C and G and F, pipette stands. I is not a coffee temp. Those are for Petri dishes for pushing the filter paper down in, because a lot of times PIs order the wrong filter paper sizes, or they come as a standard size and you either have to cut them or force them out in the plate. They do not look great, admittedly. But they are functional, and there's actually a 3D printed spring inside that. So it's got a plunger that you push down and pushes the filter paper in. J is a functional gel electrophoresis rig that is do-it-yourself, and it costs about $20 to make. And it does only work with mini gels, so they're about 3 inches by 4 inches. The K is for pouring your gel mold. L is the transilluminator. A transilluminator allows you to fluoresce the dyes in the gel, allowing you to image and quantify how much DNA you've got. The M are the combs. N is a centrifuge that is largely 3D printed. There's tons of designs out there. And O is a tube tumbler that has been passionately named Sir Tumbalot by at a tiny green cell on Twitter, or X, or whatever it's called nowadays. Sebastian Kosioba, he's one of my favorite and best collaborators for this project. He is like the king. He is a fully self-trained, has 0 degrees, none whatsoever, and he has a humongously successful lab in his home in New York City, and he is the best scientist I've ever worked with by far. And this project would not have come to fruition without him, so I have to shout him out. Bear was the first part of this, which is an imaging system using a Raspberry Pi. So it's biological, affordable imaging with Raspberry Pi. Not a super novel idea, but what we did do is we have plate imagers, imagers for the transilluminator, we have microscope adapters for all different types of scopes, and then bead mag. So bead mag was something that I developed because our lab's magnetic bead rack broke. It's literally just when you go to like Fisher Scientific, Thomas Scientific, those major scientific supply companies, they charge for what I have labeled as W right there. Those are two different magnetic racks that you buy them from them. They're machined aluminum and they have magnets glued to them, just regular neodymium magnets. Any guesses about what you would pay for? So that fits a 96 well plate. It's about this big. Well, last I checked, before inflation, it was $960 for a machined aluminum plate with magnets glued to it. That there, in PLA, and the magnets, is $15. So that is not a novel concept, putting magnets on a piece of plastic. But it is a pivotal and integral piece of equipment when doing anything involving DNA, for cleaning the DNA, processing your extractions, and things like that. We've got them for microtiter plates, which is the V version. Actually, I had a researcher from Africa contact me directly asking if I could make the microtiter version because they wanted it, and I printed like 30 or 40 of them for them. And when I do prints for research labs, we always do it at cost. So we're not making a single penny off of any of this. Because for me, that's the important aspect of getting our research and these scientific tools out there to further the science. Y in the bottom left corner is our bar magnet version rather than the little circular magnets. And then Z are the lids, and the X one is for 1.5 mil tubes. So again, the QR code takes you to the printables link, and this paper on Cobble is going to be published in the Applications of Plant Sciences Journal this October. And it is going to be completely open access, so if you're interested in reading up what we have to say about it and what went into all this, that's basically where we talk about it, and we've got some sponsorships that help provide some of the filaments that I'll mention at the end of the talk. So, Cobble, this is one of the figures from the paper where I walk you through the different things that you can print, not all of it. So the red ones are ones that we can find online. Green ones on the top are all designs that we did specifically for Cobble, and then on the right is the general process of extracting DNA. The check marks are where you would use each of those tools. So those are all the steps required to extract DNA in a professional biology lab. Okay, so essentially, you can do an entire DNA extraction with just 3D printed tools. We have, again, the image. This takes you to a repository of videos showing the time-lapse images. So I've been told to speed up a little bit. Oh, well, we're going to skip this video then, so you can watch it online. It's really cool. It's the time-lapse. Okay, well, apparently we're watching it because it won't let me skip it. Or not. There we go. Go. We're going to skip it. Okay. And the last thing is 3D plant. This is the workshop that I run. We did have to charge for it at the botany conference. They made me. I didn't want to. They made me pay for the room, so we had to make people pay. But all the companies there sponsored this workshop, and I run this at any conference that asks, as long as they can help pay my way to get there. So on average, we're saving 92% cost by 3D printing our equipment rather than purchasing from scientific suppliers. And we've got tons of, oh, sorry, that's the wrong thing. Nope. So essentially, we want you guys to help and get involved. We need as much help as we can get to get these projects off the ground. So if you have ideas, you want to become a collaborator or sponsor, donate materials and or printers, because we try to give away a printer at every workshop that we run. Prusa gave us a Prusa Mini last time to give away, and one of our workshop participants walked away with it. Give us constructive feedback for our projects. We would love to hear it. That's my personal email and all my social media stuff. And I like memes, so you get a science meme. And that's it. So thank you so much for listening to my talk. I really appreciate it. Sorry I had to rush through at the end. And I'd love to talk to you about it. I'm going to be walking around the floor, and I'll be at the Recreator 3D booth sometimes. But, okay.
Perfect. Hello, everyone. I'm Mickey. I'm here with Prusha. We run a site called printables.com, and I'm very passionate about it. I would like to talk for about 10 minutes about an initiative we have there about trying to get traditional companies to release 3D printable files for us all. But, oh, thank you. But also, after that, I would just like to talk about printables and answer your questions, and it's going to be kind of a fluid thing. So let me kick it off with this, making it a norm for companies to start releasing 3D printable files. I have a clicker, and it works. Nice. So it's almost like exactly 1 year ago when the idea crystallized that it would be great, now that we have this website and it's going well, to try to make a difference by getting normal companies to release 3D printable files. So the idea was that they would release accessories, replacement parts, some fan models. So when your knob on your washing machine breaks, you will simply be able to search on printables your name, the name of your washing machine, and you will print the replacement part. The companies would be able to highlight the community models that all of us create, and we would be able to run designer contests with them. But there was this huge problem of getting this started because, reaching out to a company and showing them this, something they've never done before, and telling them to release, STL of their model, of their product, like, no way, they're never gonna do it. Luckily, the site was kind of, the numbers were getting really nice, so there was at least some argument for them that there are a lot of people interested in this, and then it could be a huge benefit for them. So we did convince, a small set of very first brave brands to do this, to start this. So we had brands like Adafruit, Cooler Master, Framework Computer, Noctua, and they would release the first models, and it got covered by the news articles online, so it generated a lot of traction. And then the companies uploaded more models. So the question is, how does it work, and how does it look 1 year after the idea was born? So the reality now is that there are 21 official brand profiles on printables. We have, hardware manufacturers, electronics manufacturers. We have, guys like Raspberry Pi, Arduino. We even have a movie studio, Paramount Pictures, who did a promotion for the new Transformers movies, and they released the Transformers hat. It was really cool. And so what are we talking about? This is the kind of models that they release. For example, I'm very grateful for Cooler Master. They were one of the first company that started this with us. And so in the purple model that you can see on the screen, that's a replacement clip from a PC case. So, it's the typical plastic doodad that breaks on your product, and it makes the whole product just useless when it breaks. So they release the files because, they're not making any money by selling you these little replacement parts, and it's great for them to make the product, last longer, be repairable. So that's the one example. There's also the Noctua adapter. So, Noctua sells fans. And with this adapter, you can mount it to different sizes. It's really great. Butch, you want to tell? No, it's just running by. OK. We have some inbus holders, like tool holders. We have customized, when Cooler Master was working on the case, they designed several different feet for the case. But of course, they only picked one to be mass manufactured. So, but they had all the different designs, so they decided they would just release it on printables so that you can customize it to whatever you want. I think it's great. So this is how the profile looks. You can just look the brand up, and you can download any of the files that they have. The thing that I was really excited about was to do some contests with them, because I know that the brand will always, it's hard to get them to spend a lot of time making the models, but all of us love creating models for everything we have at home. So the idea was to challenge the community to create awesome models for the products, and the first contest is now running on printables with this topic. So It's for a computer case. In the contest, you can win the case itself. So it's kind of a catch-22. How do you design a model for something you don't yet have at home, but something you can win in the contest? And the way they did it is that they prepared a step file of the whole computer case, and they released it. But isn't it completely crazy that a company releases product and also releases a step file of the whole thing? So they edited the model so it's not a manufacturing file. If someone tries to make the case from sheet metal, it will be like tremendous amount of work. But for creating 3D printed files, it's more than enough. So I think it's incredible that we're getting baby steps, but we're getting there. Getting these brands to understand our community and that we love tinkering, we love modding it, and that if they provide us with models, it will be much easier. Oh, second microphone. So that's the current state of how it is. What are the future plans? It's a long run with all of these brands. We have 21 now there. We're talking to over 20 more brands, some of them really big ones. I'm hoping to get them there soon. We hope to do regular contests with these brands, so they will be releasing the manufacturing, drawings and everything. One thing that's exciting is charities. There's an Enable booth in the opposite corner of this hall, and they're making these prosthetic hands. There's also Able Gamers, a gaming charity that makes 3D printed mods for controllers, so people with physical disabilities can still play games. And there are a bunch more charities in the 3D printing world, so we would like to put them here so they have more visibility and more people can participate. And yeah, just hoping for more products with 3D printed, parts. They're just be created. The whole product will be created with 3D printing in mind. So that's Printables Brands. I hope one day. I don't hope one day your part of your product will break, but I hope when it does break, you will be able to simplify the replacement part on printables because of what we're doing. But we also have some amazing designers in the crowd. I see Fotis Mint, I see Clock Spring. There's Fernando DSK in the crowd. You're on printables, wow. So I would just love to chat with you guys about printables and about anything you want to know, anything you would like to, some features to be on printables, anything you wanted to ask about but didn't have the chance. So do we have a question in the crowd? I see a question there. Do you just run around there?
So unfortunately, the sound we keep hearing is the frequency conflict, so we're going to have to share one mic. Just really quick, I'm Pooch. I handle strategic partnerships and creator relations for Printables. So this is something that's going to become more dear to me too, and we're really excited to have some of our top creators, our top creator actually here with us. So we're going to bring him up here in a second. I'm going to come up to you though, so everybody can hear the question, and then we'll just have to pass back and forth as best we can. Do you want to come? Why don't you come with me? Yeah, okay. Just getting mobile. This is fun. All right, really quick. You tell us your name and your question.
Murray Foster, and a major source of design files for mechanical constructions is McMaster Carr. And they have a huge assembly of those parts. It would be really nice to see you collaborate with them and get all those files on printables.
That's a fantastic comment. I'll tell you, I use Fusion 360. They have a fantastic integration. We actually work with Autodesk as well. I think this is a great thing to bring up. We're all about making the whole process easier on multiple fronts. I think they'd be a good brand as well. So
there are numerous, commercial organizations that are collecting 3D parts, and aware companies, aware of the CAD environment and that everything is going towards computer construction, are making the vast majority of their parts available as CAD files, and then you can just bring those in and use them in all your constructions.
yeah, I think it's a fantastic idea. I want to see more of it. Why don't, if you mind, why don't you come in? Should we just casually kind of sit on the edge here and just have a little chat? Okay. We're going to bring Fotis Mint up here. Now, really quick, before we do that, show of hands, how many of you guys have a Printables account already? Are familiar? Okay. Does anybody in the crowd already run a club or? Okay, so who is following Photos Mint, first of all? Because I think he's the most followed. I follow him. Good. Does anybody subscribe to his club already or another source of his models? We got a couple. It's good. If you haven't, I highly encourage you to check him out. He's very talented. Why don't you come up here, sit next to me. I won't bite you. Sure. Yeah. And Mickey, you just smack me if you have a question. We're really honored to have you with us. Obviously, you've shown off. If you haven't gone over to his booth to see some of his models, please do say hi. He's a friendly guy. Really quick, I want to ask you to kick this off, and then I'm going to open this up to the crowd. If you guys want to ask Fotis or us a question as well, please continue to do so. As a creator, as somebody who professionally sculpts and models and all this stuff, we have seen the rise of more and more systems out there, websites and stuff like that, where you can post your stuff. You got started on Patreon predominantly, is that right?
I actually started in my mini factory at first. Before even Patreon, we only had a store. Well, I was mostly giving everything for free back then. So stores really started at around 2019.
Okay.
And after that, Patreon.
Okay, so you've tried a couple different platforms out there, and I want to understand what it is that maybe you've liked about some of them that you haven't, and what is it that made you decide, hey, printables could be a great new space for my thing, and how does it make it easier or better of a choice for doing this kind of thing professionally?
First of all, the first thing to me is also, always the people. I always like to have, when I'm giving my work out there, I really want to have a good relationship with the platform I'm in. And I don't like spreading myself in 10 platforms or something. I'm usually exclusive in one, maybe two platforms, and that's how it is. About printables, I mean, you remember, I was one of the first, when it opened, like that we uploaded some models there, but since then, things like in such short period of time, the website is so advanced compared to what it was. It has the best upload system. I mean, I just throw a zip file in there, and I don't have to do anything else except typing my own descriptions. The traffic is fantastic.
Half of the features that Fotis describes are there because he's just basically constantly spamming me on Facebook, and he's just like, why can't I just drop this zip file there? Why do I have to drop the individual files? And I'm like, yeah, it would be nice. And then he keeps spamming me again and again, and then I bother the developers long enough that they develop it, and that's how the site gets better. And this is how it works with all the designers who we work with.
That's fantastic. And so as a creator, and guys, please just raise your hand if you want to ask any of us anything at any point, okay? And I'll jump in, I promise. You've used different systems, you've compared them and stuff like that. You've mentioned some advantages and whatnot. Are there things that you feel like when you come across something that you wish was different? Like, does that, you just mentioned you just harass Mickey. I mean, we don't all have the advantage of doing that, obviously.
In printables, you will never be, you will never get rid of me. I mean, you know that there's, if I notice that something needs.
So I hope I will never, get rid of it.
We hope not, yeah.
I mean, if I feel that something needs to be added, like you remember new file types, for example, when we started this again, there's no way I'm not going to tell you, like, why not? It's going to keep getting better and better year by year. It's already an amazing website. And Printables Clubs is still in the beginning, but still shows the potential because we're still in beta and we have zero problems, and that's unique.
It's pretty rare. How many guys are thinking about starting a club or would be interested or just getting into CAD, maybe have some skills? Yeah, look at this. Okay, good, yeah. Yeah, question here.
So my question is, for people who are just starting to design and getting their stuff up there, how is Printables helping for discoverability for people that aren't, have a big following and they're just getting into it, because not everyone starts out with this huge audience and they're like, they might be a phenomenal designer, but how is Printables like finding to be able to promote, or are you actively doing things to engage new people who are just starting out?
It happens on several fronts. One of them is, I guess, similar to Reddit. there are like a lot of users who browse the new model section. They're like heroes who upvote or downvote like the good things. So they help get new models trending so that they automatically just get more visibility. Another thing is I and my colleagues, we go through them and we have the featured models. So we always try to pin not just like cool looking models, but also some functional parts and some really great sculpts from all designers. So that's another thing. And I guess the last one would be the search. It's, I would say, surprisingly smart how it goes through the of course the name, the description. It even kind of checks the STLs and it tries to serve you the most relevant information. I feel like the search is very often broken on many of the, like it kind of works, but when it doesn't go through everything, it can be difficult to find what you're looking for. So we spend a lot of time on that. So you can do like modifiers for search, do like, do not include anything that has this name in it.
I was going to say, I noticed the search functionality on there is stronger than other sites that I've used and turned up more accurately what I'm looking for in a much shorter amount of time. I'm not like going back and forth.
Yeah, I've noticed that as well, and I think that's actually a credit to developers because plain text search is one of the most difficult algorithms to balance out because what one person looks for and what words they use are not the same. Should we take another question?
Yeah, and by the way, there's no AI. Everyone is just throwing AI these days, like AI-powered search. No AI. It's just like well-tuned text search and just works much better than throwing some AI model at it that's just gonna throw out some random answer, and you can't tune it at all basically. So no, none of that.
Thank you. Good question. All right, we got another question. What's your name?
Dylan Hayden.
Dylan. Sorry, say it again.
Dylan.
What's your question?
Do you think you could add some kind of incentive to voting, like he said, voting new models? Like if an account has been like active enough, do you think you could add some kind of incentive of like 10 Prusa meters if you vote on like 50 models a week?
Interesting. Okay. So his question was, do we think we can add some incentive for voting on stuff? I think that's something we could entertain. What are your thoughts on that?
Yeah, I guess we already, like, for example, there are some secret, techniques in work for the people who report some invalid models. We kind of mark how good their reports are, and we secretly mark them as detectives, so their reports have higher value. So I guess we could do something similar with people who upvote good models which are very new and then they become very popular, and like mark those accounts as some kind of, secret heroes who help to find new models. That's a good idea. I like it.
We've got another question up here. And it's not creepy, but basically Mickey's saying we're watching you and we're evaluating what you do and we appreciate it. I'm gonna come over here for another question. I'm gonna pass in front of the camera real quick. What's your name?
Jackson.
Jackson, what's your question?
So one thing that I remember was on Thingiverse is there were some models that you could customize a bit. So I remember this cool gravestone model that you could have your own text on. Have you considered making any sort of customizable functionality into printables?
Yeah, I think Mickey's nodding. We've been considering it. I don't know if there's more specifics. That's a great question. Do we have ideas for enabling better customizations? I know we do that on the slicer a little bit too now.
Yeah, like the customizer on Thingiverse was always super cool. It had some side effects. For example, it auto-published every customization was auto-published, so it just filled the database with garbage. So there are some downsides. The biggest downside we see is that the traditional way to do customizable models is OpenSCAD. And these days, like almost nobody knows how to use OpenSCAD. I would argue like everyone here is like the most hardcore fan of 3D printing. Like how many of you know OpenSCAD? That's like,
you're in Sven's wheelhouse.
Like, kudos to you, but I'm afraid there's literally like only a handful of us. So we're kind of hoping if we bring this to Customizer to, I guess, just make it easier to make the models customizable, whether it's through Slicer or Like I know a lot of us use Fusion 360. If we somehow could get the, engine to pass the, there's also customizer in Fusion. If we got like to approval from Autodesk to just pass the data there and it would generate the mesh, or just create some other like way to create easily customizable models, I think we would love to do that. But with OpenSCAD, I'm not so sure if we're going to dedicate like a lot of effort into it.
I want to ask maybe one or two more questions of Fotis while we've got him up here, because it's not often that you get people from Greece coming out and visiting and sharing. I will tell you this, I know nothing of artistic, like I'm a very like technical modeler and stuff, so I don't know how many of you guys are like using CAD to do like functional parts and stuff like that, maybe show of hands. How many people are getting into the organics and like learning that kind of stuff? And so, and it's a completely different game. You've predominantly been in organic modeling, yes?
Yes, I started with CAD, but then I changed it completely because I couldn't do what I want.
So I'm going to ask you probably maybe one of the number one questions that you get all the time, because this is a new world to me, but I'm very curious. I see amazing models and applications and creativity from you. Where do you seek inspiration from in terms of like what you decide, I'm just going to model that next? Is it just like something pops into your head one day, or do you have a list that you've been wanting to do for a long time?
We have lists, but the thing is that you even if you have something on a list, sometimes, I mean many times, I'm like, I don't want to make any of this right now. It's just a matter of psychology, you know. Yeah, sometimes you don't want to make something just because it wasn't a list, you know. So that's why, you know, now I have also an art director. I have right there. So I have, when I'm completely blocked, I get the yeah, I get the push. It's good to have someone else to inspire you, or, you know, have another eye on your work. So that way you can improve, you can have new ideas, you can do a lot of.
That's really interesting, because I don't know a lot of people who do what you do, and to have an art director and start to put a team together. One of the things I think we might be interested to know as more talented designers come along, you know, what tools can we put in place to facilitate? Because Britt is your art director, but I know you also work very closely with Charo, and you have help there. And so, you know, are there tools we can put in place to make collaboration easier and things like that? I mean, these are kind of the things that go through our heads.
I mean, in my opinion, it's not. I've been working alone for a long time, and the only thing I got was a burnout. So having some other people that are very good as well to help you, I mean, to make a team that's going to help you achieve things easier and better, because you're not doing everything by yourself, and you cannot do anything, you know, all of them equally good. I mean,
sure.
Yes. So having other people to, I mean, for me personally, both of them came from the community. It's not like I went to companies to make my manual supports for resin, for example. I found a person that was absolutely amazing, and I worked with him. I mean, you can find everything in this community.
That's really good to hear. We got about 2 minutes left. We take maybe a couple more. We got one question here. Anybody else want to get us something in before we wrap up? All right, we'll take your question. What's your name?
Scott.
All right, Scott, what's your question?
So compared to a lot of its competitors, Printables has a lot of focus on pre-sliced models, and that puts a lot of power can put a lot of power over your printer into the hands of somebody somebody who wants to make your printer crash, or maybe just has some very weird settings for their exotic or very wet filament or something. What is in place, or might be in place, to, I guess, consider non-Prusa printers? Because most people without a Prusa printer want to use a Printables model, just can't use that pre-sliced G-code. So what is, I guess, in place, thoughts on compatibility with other printers and other filaments?
That's a really great question, and it's one I know we get a lot. So security around G-code and whatnot, maybe you can speak to what's in place and what we're working on.
So first of all, I would say we've abandoned this a long time ago. Like, we started the Prusa printers with this idea, and this was the number one concern, so we just dropped it. Like, I think almost no models have G-codes there anymore. Also, we opened it up to everyone, so there can be G-codes for all printers. whenever there's a printer missing, we just add support for it. And the security side of things is that we run all the G-codes through like a parser, and it checks all the commands. It doesn't allow like any, like most commands are straight up banned, like saving stuff into EEPROM. Like you just cannot, that will not be allowed to upload it to printables. And yeah, we check what the G-code will be doing, and if it's weird, we will just block it if it's like changing temperatures mid-print to something very high. So it will block it, but the short answer is that we added support for all other printers, and we are not like actively pushing this at all. We much like refocused into making it like the best 3D model database rather than really being like super like focused on the G-codes, even though that's not where the market I think is yet.
Good answer. Yeah, always room for improvement. Unfortunately, we got to wrap up here because we're closing down at the end of the day. But if you have a question, we're going to be over at the booth. I want to remind you guys really quick, if you haven't yet gone over to the booth, scan the code to get your credit for the event so you get your printables credit if you haven't done that already. I want to thank Fotis for being up here and talking to us. And I hope you guys all are having a great ERF. And if you want to talk to me after, if you want to question after the fact, I'm sorry, that's fine. Thanks, guys. Enjoy the rest of the show.
All right, ladies and gentlemen, the time is now 5:02 p.m., which means the East Coast RepRap Festival has come to the end of its first day. We just want to thank you all so much for being here. Thank you for coming out today. We had an amazing day. Let's hear a giant round of applause for everybody here today. Put them together, come on.